And here we are back with the inventory stuff that we have been working on in the past. We took a little bit of a break talking about materials and particles and all that kind of good stuff, but now we're back developing some more on this inventory. We're going to expand a little bit more on some of the concepts and add in some more features that have been requested of me in this more intermediate focused inventory follow-up. If you haven't seen the original yet, I highly recommend it. There's a playlist with all of these videos in it that just starts at the first video of the first version of the course, all the way up to and also including a bonus video in which we fix a couple of bugs and replace an entire system to be a little bit more intuitive to actually use. For now though, we're going to talk a little bit more about item subclasses, because in that previous series I talked about why we ended up using data assets for our items rather than data tables, as you might see in a lot of other inventory systems. And that is because we can take advantage of the object-oriented approach with data assets, because data assets in and of themselves are classes, meaning that they have parent classes and can have child classes. And that is very, very powerful, because our entire inventory system is based on just using the BP underscore item. But as you can see in that series, we already made a BP underscore item weapon, and that has an extra value on it, that being the damage value that we have over here. Something can be a weapon, but the inventory itself doesn't really care about that thing being a weapon. The only thing that the inventory system needs to know is, okay, this is the inventory slot that it exists in, this is the amount of it that we have, this is the image that I need to display, and so on and so forth. So we can just work with normal BP on item references in the entire inventory system, and now everything we build on top of that, all the other item subclasses that we're going to be making, that we're going to be talking about today, will still just slot in perfectly to our existing code. We don't need to update our existing inventory system in order to now expand this and add multiple different types of items. The moment a type of item becomes relevant, we can just cast the reference that we already have to the item and upgrade it to the specific type of item that we need. If that doesn't make sense, don't worry, we'll eventually get through all that. So for now, let's make another couple of subclasses. We already have the weapon subclass, so I think it makes sense to now also make something like the child blueprint class of BP item here, and we'll call this BP item armor. And this will have a float on it as well. And this float will be a defense stat. Now, if you're being very tricky, what you could do is you could probably get away with making one class that is just equipment and using the same float for both of these, and then having two like different branches for offensive and defensive equipment, that being weapons and armor. I don't think like optimizing to that degree is really all that relevant. Do make sure that they are exposed though. So we just make this two separate branches. And then let's make another one. We'll make a BP item and we'll call this one Consumable or something like that. That's misspelled as hell, isn't it? And what this will do is it will have something like health to add, which will be obviously a float as well. And then the next one will also be a float, and we'll call this mana to add. And then we'll also have a stamina to add. And now we can simply make a consumable item that when we interact with it, will add a certain amount of health, mana, and stamina to our character. We expose all those, and now we can start actually making items off of these different classes. So we already have in our item assets, we have the item sword, which I believe, yes, is indeed of type BP item weapon. But now let's also make in miscellaneous, we can make a data asset, and we can get our item weapon or armor or consumable or whatever. So let's make an armor, and we'll make this one item basic chest plate, something like that. And of course, this will have all of the values. So this will be basic chest plates for the name. Item ID is actually something that we didn't end up using all that much, and something that we probably want to set programmatically and not just through this, but we have 0, 1. So this would be item ID 2. The icon, I don't have an icon for this at the moment, to be fair with you. I have not made one. So it's just going to be this random test texture for now. And for the model, the same thing. I don't really have anything prepared for it, if I'm being 100% real with you. So what we'll just do is I will get something that seems like it will work. And that will be this table. The value will be 50 gold, max stack size. I will set this to 1 because it is obviously a tool and we don't want tools to be able to stack. The sword we also have at a max stack size of 1. And it will give us 2 extra defense points. Actually, let's go for 3 defense points. Let's go a little crazy. And that's really all nice and good. So now we can make another item here again through miscellaneous data assets. We can look at the consumable and we can make one and we'll call this item health potion. And here we can say you want to add 10 and no mana, no stamina. This will be our health potion. Of course, if we make a mana potion, we can just say, hey, you add 10 mana and no health and so on and so forth. Item ID will be 3 again. We're not actually using this anywhere, I don't think. I just implemented this in case we ever need it. There are better ways to assign values for these, to be very honest with you. But for now, this will do. The texture will be just a Purulin mask, I guess. The model will be, I don't know, the sphere. The value will be 15 coins and the max stack size will be 16 for these, something like that. So now we have a number of different items of a number of different types. Let's implement something in the potions, because for now, we'll worry about equipment later and how that works. We have that set up now. I want to actually add a little bit of code to the potion. So we can go into the BP item consumable and we can do a couple of things here. We can either make a function on this that gets the player's health and then updates it and everything is done by the item. Or we can make that functionality on the player and the item will just call that for the player. And even then we have a couple of choices. We can make that functionality inside of here, or we can make it inside of whatever widget ends up doing that. The way we're going to approach this is with a blueprint interface, because what I'm going to do is every single item in our inventory system is going to end up being interactable. So what we'll do is we'll make a blueprint interface here. We'll do that in the blueprints folder. Why not? We can just do that by coming up here into blueprints and we make a blueprint interface and we'll call this BPI inventory utils, something like that. Opening that up, we can add a interact function. And for now, that interact function isn't actually going to do all that much. It's going to have a reference to the player though. So we'll make an input for that and we'll give that a type third person character so that we can access that. And then the outputs, let's do a success output. So that will just be a bool. And every single implementation of this will return whether or not the interaction was successful. So for instance, if we try to like attack with a sword, but we're already doing another animation or whatever, we can return false for this. If we try to like take a potion, but our health is already at full, we can not use up the potion and return false so that we can maybe like use that information for something else in our actual inventory system. So now that we have this set up, this is our first function. I doubtlessly will be adding more to this interface. We can go back into our BP item, the parent one, that is. So we go into our items and then BP item, the very top one. That is the parent to everything else. Going into the class settings, we can say implemented interfaces. We add one. That will be our blueprint interface. Apparently, we already had an interaction blueprint interface system. I guess we'll just keep these two separate. We can probably merge them together. Doesn't really matter that much. But now that we have that implemented, we have this interface thing here, and we can say on interact. For the basic item, we don't need to implement this at all, because the basic item doesn't need to do anything when we interact with it. But we can come up here into the BP item consumable, and now we also have the interface here for interact. And there we can say player, and then we can run the heal player function on that player. So let's make a heal function on our player, actually, because we probably need to have that. So we can open our third person character here, and we can just make a function, or we could do it as an event, I suppose, but let's make it a function, and we'll just call this heal player. And honestly, we'll just give this 3 inputs: HP to heal. I think I called it health to heal actually in the other thing, so let's keep our naming conventions consistent, which obviously will be a float. And then we'll have mana to heal. You could make 3 separate functions for this if you preferred. I think this is just a little bit more straightforward, especially if you have items that heal 2 of the 3 stats or all 3 stats, or just do a full heal on everything. This makes it easier and more reusable. So then we need to give the player some stats. And what we could do is we could just give him a health value, and then also give him a max health value, and do that for stamina and for mana as well. I don't actually want to do that. I want to do this a little bit more optimal from just a management perspective. Performance-wise, it doesn't really matter that much. But what we're going to do is we'll make a blueprint structure, and we'll call this BP stats. And here what we'll do is in structure, the first member will be the current value, which of course will be a float, and then we'll add another variable to it, and that will be the maximum value. And I guess we could also like implement a minimum value if we wanted to, but for the most part the minimum value for all these stats is going to be 0. Just making it as a struct is a tiny bit easier to deal with, so that's the way we're going to be doing. And now our health can be of type BP stats, and we can easily make our mana as well and our stamina as well. So we get our health, we break the stat, we get our current value and our max value. We get our current value plus the amount to heal, and then we get the minimum between that and the max value. So if the amount we're trying to heal plus our current value is less than our max value, we just get the result of that addition. If it actually exceeds the maximum value, it will just return the max value instead. That's a good way to just clamp in one direction, because we don't care about the value going under 0. Because again, that's not actually ever going to be relevant. So it is a little bit cleaner than using a clamp. And we'll kind of just do the same thing with the mana and the stamina. So we'll break, we'll add some addition nodes, we'll get the current value for both of those, and then add the amount to heal, which actually, a little thing that I figured out while doing the last series is, since we're inside a function, this is another reason that functions are really nice, we can actually just get the health to heal, and the mana to heal, and the stamina to heal as local variables, and we don't have all that noodly mess all over the place, which is quite nice. And then we just add minimum nodes for all of those. It doesn't really matter if you put them into the top or the bottom pins. Functionality of the minimum node is going to be the same regardless. So now that we have all of that going on, we just need to set these values. So we can just copy over health, mana, and stamina over here real quick. And here we can simply set members in BP stats. And what you can do here is we can just enable which members we want to set. So we don't actually want to change the max value at all. There's no risk of anything being changed here in the max value, because we're not going to be accessing that at all. So we can just say, hey, we want to change the current value in this struct for all of these. And we can just like pull these down here and hook all of these up easily like that. And then just for organizational purposes, I like using a sequence for this. So first it does this one, then it will do that one, and then it'll do that one. This is effectively the exact same thing as just plugging this into there, and then that into there, and then that into there. This is just a little bit more neat. This is just a little bit more organized. So now we have the heal player function, and we can go back into the BP item consumable, into our interaction. We already have a reference to the player, because whenever we will interact with this in the actual inventory system, we'll just supply in a reference to the player. We'll get to that in a moment. For now, though, we can simply just call heal player, and we can just get the health to add, the mana to add, and the stamina to add, and just plug those in. And it's really as simple as that. Now, there was a little bit of an issue here, which is good to cover actually. I compiled before adding the success return value, which meant that when I go into my weapon consumable here, it actually implemented it as an event, because a blueprint interface function that doesn't have a return value is implemented as an event. But now, if we compile this, it's going to scream at me because it's turned from an event into a function. So we need to remove it, compile again, and now it will be here as a function instead with a success value. So we can just like copy this over fairly easily, and it will work now, and we can say whether or not it was a success. Now, in order to get a success value here, it's actually a little bit more difficult because we now need to also like look at whether or not we changed any of these stats. And I don't know that that is necessarily super relevant to what we're doing here because this is supposed to be an inventory series, not a general like RPG series. But just for shits and giggles, let's do this. So we can make a couple of local variables here. And that will be starting health, which will make a float, starting mana, and starting stamina. And we'll just set these values at the start here before anything else happens. And then at the very end, we'll just compare them to the current values of all of these stats. And if any of them have changed, it will be a success. Something happened. If none of them have changed, you clearly just clicked on a potion by accident, and we don't want to subtract that potion, right? So we'll just use the same references here to health, mana, and stamina. And here we can just split the structure pins. Alternatively, what we could do is we could, at the start, check whether or not like health is already equal to max health and that kind of stuff, but that makes things unnecessarily complicated. This is a lot easier, so we just like get our starting values, and then at the very end we add another pin to this sequence. And what we do is we add in references back to our starting stats, and we get our current stats. And now that we have the health and the starting health, and the current and starting mana, and the current and starting stamina, all stacked on top of each other, we can simply check our current health value. Is it not equal to our starting health value? And we can kind of just do that with all three of these values. So we just check, hey, has it changed, right? And then we can just hook that up into a OR bool operator here, where we can just put in all these into an OR. And now if any of these three have changed, the output for this will be true. So then we simply just add a return node here with that as the return value. We'll call this success, and that will be what happens after everything else. It's a little bit of a side tangent that we went on, but I think it is relevant to cover. So in our item consumable, we now have the success output, which we can just straight up put into the return node for the interaction interface function as well. So let's take this world item that we have over here and change the item data assets to a health potion, which is it's a big potion, I'll tell you that much. It's a little bit bigger than I thought it would be, but these are apparently going to be our health potions. So now we can pick these up, and our inventory will have these things, which apparently are health potions. Now, we have no way to interact with them yet because our inventory system left-click is just moving the item, and right-click is splitting the stack. So we're starting to run slightly out of buttons to interact with and use this potion for. Now, I personally do very much like the left and right-click capabilities of moving things around the inventory. So there's a couple of ways we can go about changing this. Number one would be having a separate inventory slot somewhere, much like these two things over here, which is something like use. And when we drop something in there, it can try to interact and see what it does. I don't personally love that. So what we'll end up doing next time is we're going to be making a hotbar, something that we can place our items into, just like any other inventory, but it will be available during gameplay. And we can highlight an item, and then if we left click with that item highlighted, that is when we'll actually use the potion. So we can't use the potion in our inventory here. This is just storage. When it's in a hotbar is when we'll be able to actually use it. All right, so now that we have those item subclasses really nailed down, and we have one for consumables that we made last time, we need to be able to use those. And I figured in order to start using those, maybe we can put them into a hotbar of some kind, because a lot of games will have something like that. So that's what we're going to be constructing here today. So let's start out by making a new widget blueprint, and we'll call that something like widget blueprint hotbar, because it'll be the hotbar. And I'm just going to put this in a canvas panel because it's going to be like up at all times anyway. We're not going to be instancing this a bunch of different times, so it's fine to use a canvas panel here. Anything that gets instanced a lot, you probably don't want to have that happen. Okay, this is going to be slightly weird for a moment, but we're going to be adding a button. And this button is more or less just going to be a way for us to detect when we enter and leave this with our mouse cursor. We're not going to be adding any on-clicking events or whatever to it. We just need this for hovering events. So we'll come over here to the background color and we'll actually set the alpha to 0. So the button itself is going to be invisible. We just use it for its functionality. And then we'll add a item grid. We made this in the inventory series itself, in the first parts, in the first segments, the first chapter, whatever you want to call it. And we can just add one of those to this button. And we'll make this fill up the entire thing. And we'll just make sure that this scales properly with the screen itself. Now, we need to assign inventory slots to this item grid, because that's what item grids do. They show the contents of an inventory. So let's go make that inventory real quick. And if we go into the third person character here, into the blueprint for it, we already have an inventory component on this, you might think. So what are we going to do? Well, actually, it's pretty easy. We're going to add another one. So we add another inventory component here, and we'll call this one the BP Hotbar inventory components, something like that. Here we'll say the inventory size will be 5. Let's actually do maybe 6. Then while we're in here anyway, let's go up here to event begin play. And at the very end here, what we'll do is we'll get the BP hot inventory component. I apparently didn't type hotbar. And we can construct that inventory. So inventory construct, just like we do with the normal inventory component. And then we will create a widget. And we're going to be creating the hotbar widget. And we'll immediately add that to the viewport, because the hotbar is always going to be on the viewport, more or less. If you want to be able to disable the hotbar, you can of course just save it out as a variable. But for the most part, you're probably not going to need to do that. So now if we start up the game, we will see that we have the hotbar existing in here. It's still empty, but we'll work on that in a moment. The reason it's still empty is that this item grid doesn't have a inventory component assigned to it. So the way we do that is much like we have in the past, is adding a inventory component, and that'll be of type inventory component. Who would have guessed? And this one we will make instance editable, of course, and then we will expose spawn. So now if we go back into the third person character, we right click the create hotbar widget. We can refresh this node and we now have this inventory component input, and that's where we can put in the hotbar inventory. And once we've done that, if we are back in the hotbar widget blueprint, we can get our item grid and we can set the inventory components on the item grid. We can do this on event pre-construct if we want to even. So pull in the inventory components, put that in there, and there we go. And much like we do in other inventory screens, what we'll actually do is we will grab the item grid here as well. And then on event construct, we want to update the item grid right away, just so that once it has the inventory component assigned to it, it will actually like render out the inventory slots itself. And with that, we can now see we have the hotbar. Obviously, it's a little bit like too wide at the moment. And there's a few different things that we could do to fix that. What we could do is we could go into the item grid, and then in the rep box, we can set the horizontal alignment to being centered. And that way, when things get added, they get added to the center, which looks a little bit neater. But the issue with that is that then if we open the inventory itself, it'll also start adding them in the center here, which by and large, probably not that big an issue. But it could be slightly annoying and not exactly what we want. So one other thing that we could do is in the event pre-construct of our item grid itself, if we plug in the rep box here and we set the horizontal alignment, we can make this a variable and make that instance editable. And we'll call this rep box alignment. We compile that. And then when we go into the hotbar, we can see over here we have the rep box alignment, and it's set to fill horizontally, but we can just set this to center horizontally instead. And this will now still be outlined to the center. But if I go into the third person character here and I go into this inventory component, say, actually, I want to have 18 slots. And we open up the player inventory screen itself. So that's this one. and we go to this item grid over here, we can set this one to be aligned to the left instead. Aligning it to the left probably should be the default value. So if you just go back into the item grid real quick, go to this variable, probably set this as default to left aligned, because we probably never want to use fill, to be honest with you. And now we can see this is still aligned in the center. We open the inventory and this is now aligned to the left. So our item grid is now a lot more versatile to use in a bunch of different types of scenarios. And without adding any more code, we can pick up some of the items that we have in here and we can immediately start putting them into our hotbar, because it essentially is just another inventory container. And it works the exact same way that it would in a chest, except both of these just exist on the player character. But we don't have anything to select what slot is currently active or selected in our hotbar. And that's kind of an important part of the hotbar. So let's take a look into that next. So in our hotbar widget blueprint, we're going to be adding two more variables. And number one will be our selected index. And that will just be a normal integer. This is going to keep track of the index in the array inside of our rep box of which of our slots is currently selected. Then we're also going to have a reference to our currently selected slot. This is going to be a widget blueprint item slot object reference. So the very first thing that we're going to do is we're going to be making a couple of new functions. Function number one that we're going to be making here will be get current selected slot reference. And this is just a function to do exactly what I just said. So what we're going to be doing is simply just adding a return node. We'll get our item grid. From the item grid, we'll get the rep box. And in that, we'll get child at a certain index. And that index is just going to be our currently selected index. And we're just going to return that child value. Just as easy as that. We'll set this to be a pure function, so that it becomes one of these green nodes that doesn't have execution pins, because there's no execution happening here, it's just getting a value. And then we'll make another new function here, and we'll call that set selected slot. And in that, we're going to be using the get current selected slot reference pure function that we just made, and we'll get the output from that, which will just be a generic widget object. So we'll need to cast that to our WBP item slot. And then we'll set our currently selected slot to that output value. And once we've done that, we will run the set selected function on that, which effectively only does one thing, and that is just change the brush so that it has the outline on it. So now that we have all of that set up in event construct in our widget blueprint hotbar, after we update the item grid initially, we can just set slots that easily. And this will by default, since the selected index will be a value of 0, get the first slot selected. So now if we just play the game, we can see that the first slot will be highlighted because it is selected. The value for this will be referencing that first slot. This index is at 0. Everything is good. Now, next up, what we want to do is we want to make something that can allow us to choose which slot is selected. And we're going to do this in two different ways. We want to be able to do this through our keyboard key. So that's 1, 2, 3, 4, 5, and 6. But I also want to be able to scroll through like this, right? I'm zooming in and out, but you get that point. Like most games with a hotbar, you can scroll through. So we're going to be able to do both of those. And for those, I'm going to go into my third person here. I'm going to go into inputs. I'm going to open up my input mapping context because we're going to be adding something to that. And we'll go into the actions here and just make some new ones. So we have in inputs, input actions. This does require you using the enhanced input system. But by this point, like if you're working in a new Unreal project, you're probably already on the enhanced input system. We'll make an input action called hotbar. And then we'll also make a input action here called input action hotbar scrolling, or just hotbar scroll, something like that. And the only thing that's really important to change about these two is we're going to open up hotbar scroll, and we'll change the value type here from digital bool to being a axis 1D float, because scrolling up and down with your mouse wheel, just like moving it left and right or up and down, will give you a float value that you can then use in order to drive your code with. Otherwise, it's not going to have a float value output. So we're going to do it like that. Then in our input mappings, we'll just add these two mappings, input action for the hotbar and an input action mapping for the hotbar scroll. The hotbar, what we're going to do is we're just going to assign every single number key that we want. So 1, 2, 3, like we have 6 in total. So just 2, 3, 4, 5, and 6. We don't need that last one. And we're going to write a little function that takes in this input action and then is going to figure out which actual key we pressed. This is the easiest way to set this up as one input action. Otherwise, you can make separate input actions for every single key if you want to, but this is the beauty of the enhanced input system, allowing you to do it like this. And then for hotbar scroll, we just simply use the mouse wheel axis. So with those mapped, we can go back into our widget blueprint for the hotbar, and we can add those input actions for hotbar and one for the hotbar scroll. And you'll be able to see that because the hotbar scroll is a one-dimensional axis for a float, it has this action value that is actually usable for us. This is just a bool whether or not it is being pressed or unpressed, I suppose. One thing that I should point out is that these input actions only will work if your input mode, like if we get player controller, we have the different input modes, right? So we can set input mode to either game and UI, the game only, or UI only. In order for these input actions to recognize, you do need the input mode to be either game only or game and UI, because these are being picked up by the game itself. The moment you set your input mode to UI only, so maybe if you like open up an inventory screen or whatever, these are not going to fire anymore, which should be fine, because if you're in an inventory anyway, if you have a widget open that is like purely UI interaction based, you probably don't want to be messing with your hotbar anyway. So let's get started with the more annoying one of the two, and that is the input action for the hotbar, because for that, we want to find out what actual key was pressed, and we can make a function for that. In my own testing projects, I just make that in here, but it is actually probably better if you make that in a blueprint function library. So if you go into here, into blueprints, we can make a blueprint function library, and we can call this like BP utils for utilities, and that creates our new function. So we can call this find pressed key. Find pressed key is going to take in an input action. So this will be the input action of type, you would never guess it, but it'll be of type input action. So input action here, the object reference. And then we're going to do some magic stuff with the enhanced input system. So for that, we need to get the player controller first. And this might be a different type of get player controller than you're used to, because it takes in a world context object. Because this is a function library, it doesn't actually exist in the world, so it's going to need to be given that context. Little cut in during the editing here. For the world context object, what you want to do is you want to make that its own input here, because it's going to need to have an object that actually exists in the world to be able to get the player controller. Then when we have that player controller, we can get the enhanced input local player subsystem, which is a reference to a bunch of functions to do with the enhanced input system. And with that, we can query the keys mapped to an input action. So we can get this input action in here, and that will give us an array of keys that are mapped to it. So it'll just give us an array that says 1, 2, 3, 4, 5, and 6. If for whatever reason you have like remappable keys, this also then does give those remapped values, which is quite nice. For now though, we're not going to be bothering with that, and we'll just do a for each loop, and we'll hook that up. And that will get us the individual keys. And for each one of those, with our player controller, we're going to check is input key down, and then we'll just hook up the input key in the for each loop to that. So just going to iterate over every single input that could possibly be firing this input event, and checking for all of them, is it currently down? If it is currently down, we'll add in a branching node, we'll return. And when you return in a function, it also ends any like looping. It's just like the end of the function, right? So we don't have to worry about looping through the rest of this because it's not going to. And we'll return a value of whatever array element we were at that time. So this is a nice little function that we can now reuse in other places in our game very easily as well. Put in an input action, and it's going to return us the actual key that was pressed to trigger that input action. So with that, let's open up this input action for the hotbar and say find pressed key, just as easily as that. And we're going to do that on started. And once again, I'm cutting in here real quick in the editing phase because I didn't have this word context object in there originally. You can just get a reference to self and put that in there, and that should be all that's required. And then with this array element, we can use this to make a new function. So let's make a function here. Again, we're back in the WBP hotbar. So let's make that function, and that will be our update selected slots. In there, we'll take in the input of the key that was pressed, which will of course be a key, just simply the key structure, nothing else more fancy. And for those, we'll just check if it is equal to all of the potential options. We can hard code this with a bunch of branches, but we can also do this a little bit more cleverly, because we can still get the player controller, and we'll do something very similar to what we just did a moment ago. So from that, we'll get the enhanced inputs local player subsystem. We'll query the keys mapped to an action, and the wonderful thing is you don't actually need to have it like in your blueprint, a reference to it. These input actions, because they're assets, we can just get them from a drop-down menu. So we can just check the input action for hotbar from that, and we can once again just do a for each loop over those, and we can check, hey, is this one equal to the key that has just been registered as being inputted? Because if it is, then we're going to move forward and execute the rest of the code, which the most important bit of which is going to be our currently selected slots. We're going to set that unselected, which again, set unselected really only changes the image. So we'll do that if this branching node is true. And then we'll set our currently selected index to correspond to the array index of the for each loop. And the wonderful thing about this is that because it goes through these in order, it's also going to line up perfectly to your hotbar slots themselves, because hotbar slot 1 is going to have an index of 0, array start at 0, of course, but also the input corresponding to that is also going to be at array index 0, right? This is array index 0, this is 1, this is 2, this is 3, this is 4, this is 5. So we can very easily just use the array index here. And once we've done that, we can simply set our new selected slots. And then with all that, we can update the selected slots to use whatever key we just found was pressed. And now when we go into the game, we can see that we can switch our slots with our 1, 2, 3, 4, 5, and 6 keys to whatever we want. So that is one half of selecting the slots. Now the second half will be the scrolling bit, which actually is, believe it or not, a lot simpler. If you have, every time you scroll your mouse in a little bit, it goes in like these steps, right? And if you have like a smooth mouse scroll wheel, you don't notice as much, but it still goes in these steps. And every time you go up or down a step, this will trigger, and the input action value will either just be +1 or -1. Exactly. So even though this is a float, it's going to only be returning integers for this specific action. That just means that we can either increase or decrease our currently selected index by that value. We do need to write a little bit of logic for it to be able to wrap around, but that is really, really easy. So first things first, of course, what we're going to do is we're going to get our currently selected slots, and we're going to set that as unselected, started. Then we'll get our currently selected index and try to see what that is once we add the input action value, which again is going to be either just +1 or -1. So it's going to be selected index +1 or selected index -1. Just to be sure we can then truncate it. Unreal is going to add this note for us otherwise anyway. And here we want to check whether or not it is less than 0 or greater than 5. Why 5? If you don't quite get that, we have 6 inventory slots labeled 0 through 5, 0, 1, 2, 3, 4, and 5. So if it is greater than 5, it's 6 or above, which doesn't correspond to any of our inventory slots. So if you have 10 inventory slots, you want to check whether or not it's greater than 9. And we can put in branching nodes for both of those. So let's hook both of those up. We first want to check this. If that is false, we're going to be checking this. And if that is also false, then we very simply just set our selected index to be equal to our selected index plus the input action value that we made down here. The truncated version, obviously. Truncate just gets rid of the decimals and makes a float into an integer without like any rounding logic. Then next up, if it is greater than 5, or again, depending on how many inventory slots you have, a different value, we're just simply going to set it back to 0. It's going to wrap around to the beginning. And if it is less than 0, so if it goes into the negatives, we want to wrap it around to the end, which again is going to be the same value as this, in our case, 5. And with that, we simply set our selected slots. I told you this was actually a lot easier. This is much more straightforward to set up. And now if we do this, we can also scroll through. I do notice that for me, like I'm scrolling down right now and it's going right to left. And when I scroll up, it's going left to right. Depending on what you like, you might want to have this the other way around. I want to have this the other way around for now. So I can go into my input action mappings. I can get the mouse wheel axis. I can add a modifier to it. And we will add a negate modifier, and that just flips positive and negative directions. So now that I've done that, it makes a lot more sense to me. So when I scroll toward me, it's going left to right, and when I scroll away from me, it's going right to left. Now, the very last thing that we want to do is, now that we have all of that stuff set up, we want to be able to use the item in our hotbar. So for that, we're going to go back once again into our input actions here, and I'm going to just make one more, and we're just going to make an input action for use item and add that to our input mappings here. So I'll just make one more input mapping here. This will be for use item, and the mapping for this will like be the E key or something like that, whatever we want, right? Logically, we could make this left click, but left click already does other stuff as well, so that might be a little bit confusing. And once again, going back to our WBP hotbar, we can add the input action for use item, which again, do pay attention to the fact that you need to be in input mode, game only or game NUI in order for this to recognize. So you can't use these items from your hotbar while your inventory screen itself is up. We'll get our currently selected slot though. Just for safety, we're going to check whether or not it is valid. It should always be valid, but you never know. And then we're going to get from that the actual inventory slot structure, which we will split. We'll get the item asset out of that. There as well, we're going to check whether or not that is valid. This one actually is important because this is checking whether or not the slot itself has an item in it. If there's no item in it, this is not going to be valid. This is only going to be valid if it has an item inside of it. So then we get the inventory components for the hotbar that we set up earlier in the video. We're going to get the owner from that, and we will just cast that to the BP third person character. You can also just get player character for this. That works just as fine. But I do think it's worth showing that this is a way to do it as well inside of this widget, in case you need to get an owner of something that isn't the player character. And then using the item assets here, we can use the interact blueprint interface that we made in the previous part. And you want to use the message version of this. We can just put in the player that we just cast to. In this case, we do want to remove the item after using. So let's put in a branch, say remove item. We'll get our inventory component here and use the subtract item function that we've made in the past. And we want to subtract from our currently selected slots, get inventory slots, and if we split that open, the inventory slot index. For the most part, it probably should always be the same as the selected index that we have in this blueprint as well. But in case something goes wrong, something is a little wacky, something is a little bit weird, this will always be a lot more consistent because it's actually referring to that object, that actual inventory slot. Now, after we use up an item, it's going to refresh the inventory, which means that it's going to override the actual outlined slot that we have, which is a little bit annoying, but that's just how redrawing the inventory works in our system. So the easiest way to fix that is just to set our selected slots again. I just run that function again, and that will run the set selected, just changing the brush on the corresponding proper inventory slots. And now we can finally test the potion that we made. So let's pick up these potions, which are very big in the world. I'm going to put them in this slot over here. There's one more issue that we're going to need to fix, and that is if you see here, I can hover over these and these become selected, which for the most part is still behavior that you maybe probably do want to have for like player feedback. But then if I cancel out of the inventory slot itself, you can see that it stops highlighting whatever was just highlighted and nothing is highlighted. Now we still have a selected inventory slot. If we start scrolling, it'll update, but it's a little bit ugly that it removes the highlighted inventory slot. So what we're going to do in a moment is we're going to use that button. Remember when we set up that button to just run some code to update that whenever we unhover the button or whenever we unselect the button. But for now, we can see we can use this and it uses up one item. We can see the stamina and mana were 50, but our health got upgraded to 60. And then if we use it one more time, our health is now 70. And if we try to use it one more time, of course, we don't have any potions, so that doesn't work anymore. And back in the widget blueprint here, if we just go to our button and we say unhovered, we simply set our selected slot, and you will notice that that's going to make things function a little bit better. So if we pick up these things again, so if I hover over any of these slots, it's going to highlight whatever slot I have my cursor on. But the moment I make my cursor leave the hotbar, it's going to snap back to whatever slot was selected. So I can still select a slot like this, then it's going to highlight them over here. You will note that the slot itself keeps also being highlighted. There's a little bit of an issue where if you hover over it and then unhover over it, the highlighting for it disappears. But the moment I leave this again, it's going to snap back to that. And if I go select this and I close the inventory, you can also see that it snaps back, because that technically counts as being unhovered because we don't have the cursor over the hotbar anymore, because the cursor's nowhere. The cursor doesn't exist anymore. Now, if you really wanted to fix that last little issue, we could also go to the button and say unhovered. We can get our currently selected slots and we can set unselected as well. And I'll change the image of the selected slots the moment we enter this hotbar, as you can see. So now it immediately disappears, so we don't have that issue that we had before with like potentially two things being outlined and being a little bit confusing and a little bit iffy. So this honestly just a visual bug, but it's a visual bug that you probably don't want in your game. So very easy to fix, very easy to set up everything around that, and we have a working hotbar now. Look, I want to make a crafting system to go with our inventory system because we have all of these items, but now what can we do with them? But before I can make anything to do with crafting, we need a way to query the inventory. And what I mean by that is we need to be able to take an inventory and just check, hey, do you have this item? And how many of this item do you have? Because if we're going to be able to do some crafting stuff, we need to see, okay, this crafting recipe takes 5 wood and 3 stone. We need to be able to check whether or not those are in the inventory. And at the moment, we don't really have a convenient way of doing that. And once we've implemented a query system, we can also do other things like having specific doors in our game that take some kind of resource, like gold out of your inventory, or maybe you need to have a specific item like a key in order to unlock a door. That's all going to be very easily implementable once we can query the inventory like that. So let's open up our inventory components here, because we haven't done that in a while. We have a bunch of functions here already, some of which I don't think we actually use anymore. I don't think like the swap slots function gets used anymore since we updated the drag and drop system, but let's ignore that for now. We're going to be making a new function here and we'll just call that query inventory. The function itself is actually going to be remarkably simple. We just get the inventory array and we're going to loop over that, obviously. We need to check every single inventory slot to see if it holds a certain item. In that, we're going to break the inventory slot structs to get the information out of it, and we will just simply check whether or not the item asset is equal to our item asset that we're going to be inputting. And let's call this input the item to find. Got something in here during editing. If you just pull off of this equal node here and put that in as your input for your function, it's going to be a generic object reference. And we want this to specifically be a item object reference. So we want to make sure that it is a BP item instead. Now, in order to make this a little bit more usable and a little bit more simple, we're going to also be checking whether the stack size is greater than or equal to a amount that we're going to be looking for. So we do that as well. We'll just call that amount. There's one thing that I do want to note, and that is with this simple version of the query system, if you have 2 stacks that add up together to having that amount of that item in your inventory, this is not quite going to register that because it's only going to be checking the inventory slots one at a time. What we'll do here is we'll check both the item asset and the item amount, and then we're going to check that on an AND. So both of these need to be true. And if both of those are true, we're going to go into a branching node. We will add in a return node. The return node is going to have two outputs, and the first one will be found item, and the second one will simply be the array element that we found. So that will be the item slot or the inventory slot. So inventory slots. And of course, in this return node, the found item will be true. If we make it through the entire for each loop without finding something, we pull off the completed pin and we add a return node for found item false. And of course, that doesn't have an inventory slot to go with it. This is the entire query function, the simple version. Just to show off how you can make the slightly more complicated version that will return you an array of inventory slots that are relevant. I will make two versions of this. So we'll make this query inventory single slots, and then I will just duplicate this over to query inventory multi-slots. The input will still be the same. We still have an inventory. We're going to be for each looping over this, but we're going to be making a couple of local variables. And the first one will be the amount found, which will be an integer. And then we'll also have a second one here, which will be the slots that we have found. And that will be of type inventory slots. And we will make that one an array. So what we're going to be doing here is we're going to be changing a couple of things around. We're going to, for now, get rid of both of the return nodes as well. And once we have found an item, we first want to check whether or not this is greater than or equal to. But we want to actually check whether or not the amount found is plus the stack size is greater than equal to. The amount found is going to start out at 0. But once we have found something and it is by itself not greater or equal to, then we just add it to the amount found, and the next time we find the slots, it will be able to add those things together. So also get rid of these branches here actually, because we need to do some other stuff. So in this version of the function, the moment we find an item that matches the item that we're looking for, we're going to be adding that to our array slots here. So we'll add to that, and we'll just add the slot that we are currently working with. So we'll put in a branching node for that, and the equal check here is going to be the first thing, then we'll add. And after that, what we'll do is we'll check, is the amount we already found plus what we have in this slot going to be equal or greater than the amount that we're looking for? Because if so, what we'll do is we'll then do a return. And the outputs for this one are still going to be found items, which will be true in this case, obviously. But then also the inventory slots, plural, because, of course, this is going to be of type inventory slots, but this will be an array that we're going to be returning. And of course, that will be the slots found array that we've made here as a local variable. If the amount found plus the stack size of whatever we just found together is not sufficient to trigger this return node, what we're going to be doing, we're going to set the new amount found to whatever this value is. So the old one plus whatever stack we just found. And then it will go to the next inventory slot and it will check the same thing again. Is it the same item? If so, it's going to add it to the slots that it has found. Then it's going to check, hey, does adding everything in this slot make us go over the amount that we're looking for? Yes or no? If yes, then we can actually finally return. If no, we're going to keep going and keep going and keep going. And for this one, it's actually very, very easy, because if we ever reach the end of the for each loop without getting to this return node, we know that the entire inventory altogether doesn't have the right amount of resources for what we're querying for. So in that case, we can simply just return with an empty return node. So this is a slightly more complicated version of it, but it might be useful to have both versions for a single slot, which is just the easiest to set up. And for the most part, what we're going to be using, but sometimes maybe being able to check multiple slots together, especially for things like the crafting system, is going to be quite nice. So for testing purposes, what I want to do here is I just want to make a new blueprint class, and we'll just make that an actor. And we'll call that something like BP door. And I'll add a cylinder, just because, as well as a sphere collision. The sphere collision is going to have a radius that is quite a bit larger than the cylinder itself. And then in the event graph on begin overlap, we just check, is the other actor equal to get player character. If it is, we'll get the player character's inventory, so we get inventory. I should point out that this just returns the main inventory components and not all of the different inventory components that we have, so it doesn't return things like the inventory component for the hotbar. So if you have an item on your hotbar, it's not going to be queried in this case. We could update this to return an array of inventories so that a actor can supply all of their inventories when being requested with this blueprint interface. At the moment, I don't care enough to do that, but you could if you wanted to. And then we're going to use the query inventory. And this one, we can just do a single slot. We will only just check whether or not we have at least one of these. And then we can check for, let's just check for the sword real quick. And then if it has a found item, what we will do is from that inventory component, we'll just subtract an item. And item we'll subtract is going to be from the slot that the sword is in. So that's going to just like take that index, put that in there. And then at the very end, we can like destroy this actor, the BP door, that is, because it's a door. You can make it play an animation instead or whatever. So if we put this into the level here, just in a random place real quick, we can see if we walk up to this, nothing happens. But if we pick up the sword and we walk up to it, it'll disappear because it queried the inventory. It saw, hey, you have a sword. If we open the inventory now, we see we don't have a sword because it deleted it. And that's how you can very easily make items, blueprints, things in the world that query your inventory and check for you to have a certain something in order to be able to progress. And while we're at this, because I mentioned it, there's actually, instead of changing this to an array, what I would probably prefer to do is keep the inventory slot itself here, but then also add in an array for any extra inventories, and you can just like make that into an array like that. So every bit of existing code will still work because of course it's still just displaying itself an inventory. But now if we go into our third person character, for instance, what we can do is in this blueprint in the get inventory, instead of just returning the inventory components, we can get both of these together. We can make an array out of that and then return that array as well. So if we need to, for whatever reason, get both of these inventories because we want to query both of them or whatever, we now can. So that makes it a little bit more intuitive, because otherwise, if you have something in your hotbar, it's not going to be able to query it or whatever. It's a little annoying. So going back into that door, if we like compile and we go into get inventory, what we can do instead is we can put that into a for each loop. So no matter what character interacts with this, how many inventories they have, it will also always work. So do a for each loop, switch the target around, loop body, and now it'll also work with the hotbar. And then also the subtract item needs to be taken from the loop, of course. So just to show you that, we can now pick up this sword if we wanted to, and we can just put it in the hotbar. And if we walk up to this, it removes it from the hotbar as well. So we have a good querying system now for the inventory. And with a good querying system means that we can look through the inventory for specific items, and that's going to be the cornerstone of being able to set up a basic crafting system. All right, crafting system coming up, let's go. We set up a query inventory system last time so that we could now set up a crafting system. So we're going to write the code for all that and set up our first crafting recipe. So let's start by creating a crafting recipe, because we can't make anything if we don't have a recipe, right? So we're going to make a struct for that first and foremost. So blueprint structure. And this will be our struct crafting recipe. And in this struct, we're going to do something a little bit weird, because the struct is only going to have one entry in it, and that'll be the actual recipe. And you might be thinking, how do we do a recipe with one value? Well, the way we do that is by creating a map worth of items. So we have our BP item here, and then instead of just a variable, we're going to make this into a map. And the value for it will be an integer. So this way, we'll be able to add as many items as we want and the amount that we need for the recipe. So this is not going to be a shaped crafting system like you see in a game like Minecraft. It's more going to be along the lines of the more popular survival games, where you just need to have them in your inventory and then you can click on a button and craft it in a crafting menu. And you might be thinking, why do we need to make a struct for that, right? Because that seems a little bit stupid. That is because every single one of those is going to be a recipe in and of themselves, of course, and we're going to store all of those simply in a data table, just to have a central place to keep all of those things. And in order to make a data table, you need to have a structure for the data table to take. So this will be the str crafting recipe data table, and we'll call this data table crafting. And in here, we can start adding whatever we want. So we can add our first entry and we can name that row something. The row names don't really matter, but let's call this damage potion. That's the thing that we're going to be making here today. And the recipe for that will be, number one, we'll take a health potion, just one of them. And then number two, we'll also take in some rocks, and we'll take 5 rocks to make that. Now, we can set this up in a number of different ways. We can go back into the struct and add in a second map here that will be the resulting items. And I think that is the easiest, most procedural way to set this up. You can do this on an individual basis in like your UI widgets and stuff like that, but we're going to be doing it like this. So this will be the resulting items. And the wonderful thing about it is, because it's also going to be a item map with integers, is you can return multiple items, multiple different items very easily with this. Now, do keep in mind that that might lead to some issues with the inventory getting overfilled, and you might need to build in protection for that if you end up having crafting recipes that return more items than they take in. For the most part, the idea behind crafting is that you get rid of some items and then get less items back that are better. So generally probably not going to be an issue, but something that you might want to take into account. So let's go into our items here and the item assets, and then I'll just copy over the health potion that we already have. We can just duplicate it, and we'll call this damage potion. And this will do the exact opposite of a health potion, damages. So let's say damage potion. And then with that, we're going to change the icon. I also added in a icon for this because I really felt like we needed to. And I made a damage potion icon as well. And this is going to be taking off 10 HP instead. And the resulting item from the recipe that we just made in our data table, so health potion and 5 rocks, is going to be just 1 damage potion. So we add in a damage potion and we set that to 1. So now that we have 1 recipe added to our data table here and we have everything set up, let's go into our inventory components, which I think is just in the root here, and add a function for crafting. We already have our query single slots and query multi-slots. We're going to be using the query multi-slots for this crafting system. So let's make a new function for craft item, and let's capitalize the I there properly so that it's a little bit more readable. And this is going to simply take in an input for a crafting recipe. So we'll take in the recipe, and that will be of type, of type recipe as well, like crafting recipe. There we go. And we'll just craft these one at a time, much like we have in the inventory system itself, where we're adding and removing items one at a time. You can adjust things to make them allow you to add multiple at a time, but that does create potential for like overflowing item stacks and that kind of stuff. So I personally prefer to just add them one at a time and just add them on a loop. If you're gonna have a game with items that could iterate millions of loops in that way, you probably don't want to do that, but most games won't run into an issue like that. Anyway, so when we get that recipe, we just break it and we get the recipe and the resulting items. And the first thing we want to do is we want to check the resulting items and whether or not there is enough room in our inventory left to add those items in. Now, you can make this very easy or very complex. What we're going to do is we're just going to get the keys from this and we'll check the number of keys that we have, the length of that. That is the amount of items that we're going to be getting back. We're just going to look into whether or not we have that many empty inventory slots. You could do something where you also iterate through and see, hey, do we already have a slot with this item? And if so, does that slot have enough room in it to get these items in it as well? But that then creates potential issues with stacks that might be able to take part of it in, but not all of it in. And it's just a lot more bothersome to set that up. If you really need that to be the case, that is the basic rundown of how you do that. But for the most part, just checking, hey, do I have enough empty inventory slots is probably good enough. So that requires us to have a function that returns the amount of empty inventory slots. So let's make that real quick. Get empty slots amount. I don't know, something like that. Which we'll add a return node for, and the output will be the empty slots, and that will be an integer. And they will just get the inventory array, do a for each loop over that array. We'll make a local variable here just to count. Honestly, we can just like call it I or something, but count is a little bit more descriptive. And they will just set the value of count to increment. So we can actually just use the increment function for that, increment integer. Whenever we see that this array element has no item. So we get the array element, we break it, we add in a branching node, and when that is false, we add 1 to our count, and that's going to be our entire for each loop. And then at the end of the for each loop, we complete, and we just return the count. So this is a very simple, easy function to let us know, hey, how many slots do we have that have no items in them? Which again is why I like having this has item bool. You can very much just like check whether or not this is equal to 0, but that leaves you open for like mistakes a little bit more. And also requires you to do this 0 check every time you want to check whether or not something has an item, rather than just having a bool for that. So that's why I like having that around. So now that we have that function, let's go back into craft item, which is what we were working on. And we can just get the empty inventory slots and we can check, hey, is this less than or equal to the length of the amount of items that we're going to be getting back? Putting in here during the editing, I obviously made a mistake, and it's a very easy mistake to make. A mistake that you probably make all the time is I put these in the wrong order. So now it's checking the empty slots amount. If that is less than or equal to the length, which is not what we want to check whether or not this is greater than or equal to. So we check greater than, or rather actually greater than or equal to. Or you can just put these two pins around, but this makes it a little bit more readable. So greater than or equal to, not less than or equal to. Easy mistake to make. I make it all the time. And if so, then we move on to the rest of this function. If not, we don't even need to attempt to craft anything. We don't even need to look if we have the recipe completely in our inventory or not, because we're not going to be crafting anything anyway, because we don't have the inventory room for it. So there we can return. And I suppose we can add like an enum or a string at some point that can maybe give a little bit of feedback for early returns, because we're going to have a few different ones here, but we'll probably circle back to that a little bit later. Assuming that we can fit our newly crafted items into our inventory, what are we going to do then? Well, we're going to get the keys from the recipe now, because we need to look whether or not the recipe itself is actually viable. So instead of having these noodles go all over the place, we can just get recipe, because it's also a local variable. When it's an input like that, we can split that structure pin and we can just get the keys that way. It's a little bit cleaner. And once again, we're going to be doing a for each loop over all of that. So now we're going to use our query inventory. So we can actually just pull that in. And we can check the item to find and the amount of items that we need to find. So the item to find will be the array element, because this map has 2 columns to it. Number 1 is the keys, which is the items that we're looking for. And then it's the values, which is the integers, which is the amount. So we can just use the key as a item to find. And then using this same recipe map that we have here, we then use the find function. And we're going to be finding the key that is in the for each loop. So that we're looping over all that. And that's going to return the value integer, which is just the amount of items that we're looking for. And we're going to be doing that for every item in the recipe. Now, if at any point we run into a scenario where the items were not found, so we don't have enough items of any particular type in our inventory to do this crafting, doesn't matter if we have half the items, we need all of the items. So if this is false, we are going to again early return. Just cancel out of all of this stuff. We don't need to move on. We just add in a return there. Now here we're going to do something slightly weird and tricky. Even though we don't know if we have all of the items yet, because we're just looping through the items to query the inventory, we're already going to be removing the items that we want to use to craft. And that is because it is easier to keep track of the items that we have removed and add them back in if it turns out that we can't fully craft this thing, than it would be to put those items to the side and then pull them back in once we are sure that everything is all right. So what we're going to be doing is, if it has found the items, we have these inventory slots that the query inventory gives us, which, as a reminder, is a slots array of just the slots with those items in them. And for that, we're going to make another one of these, let's call this slot counter variables. And before we go into this, we do want to make sure that we always set this to 0. as the first thing that we do. Now that we have all of that, we can get a reference. It's important that there's a reference for what we're going to be doing in a moment to the inventory slot that we're going to be removing things from first and foremost. First thing we're going to do is we're going to use the remove item function that has lived on our inventory forever. And we're going to be running that the same amount of times as we need to remove items. The way we're going to do that is with a for loop, not a for each loop, just a normal for loop, where the index will start at 1. The last index will be the return value here of the finding node. We'll hook that up to the true value of the branch, and then in the loop body we'll just remove the item. But, and this is the funny thing, is because we are just passing in an item slot that we're going to be finding on the inventory itself, the inventory slot that we're getting here is a separate array that exists in this function. It's not actually the inventory itself. So if we remove something from the inventory, it's not going to be removed from the corresponding slot in this array. And that's a little bit annoying about how we set that up. But it's also not that big of a deal, because since we have this as a reference, we can also just set a member in inventory slot. And the member that we're going to be setting will be the stack size. And the stack size will be equal to the stack size that we had. So we're going to break this simply just -1. And after we set this, we're going to check whether or not that stack size has decreased to 0. So we're going to, once again, pull off of this stack size. And we're going to check whether or not this is now 0. Because if it has become 0, the stack is now empty. And we don't need to do anything about setting the has items and like clearing out, because this is an entirely temporary array anyway. So the only thing that we really need to do is we need to get our slot counter and just increment that so that it starts looking at the next slot. If we are in this part of the code anyway, we know that this bool is true, so that the inventory as a whole has enough items to do this part of the crafting anyway. But that's just for the first item. It goes through this for every single item in our recipe. So what if we end up in a situation where we had enough of the first item, but then when we start removing things from the second item, we find out that, oh no, actually, this was bad, because we don't actually have enough of this second item to finish the crafting, but we've already removed everything from the first item. So we're in a bit of trouble. And that's why we're going to be keeping track of the items that we have used, so that if we need to take a step back and refund those items, we can. So we can simply add in another map here, and that will be our items used map. And this will be just like the other maps that we've had. This will be the BP item type for the keys. So that's just BP item object reference. And then we'll make that into a map, and the value will be integers. After we figure out, hey, the items we found, that's okay. Like this slot, the amount of items, this item, the amount that we need, we have. Because we have that bool check right here. When we find that out, we're just going to get the items used, a map that we just made, and we're going to be adding to it. And what we're going to be adding is we're going to be adding the item from the for each loop, which, as you recall, is the keys from the recipe map. And then we're also going to be using the recipe map again. We already added in a find node for that. So we're going to also find the amount that corresponds to that, and we're just going to add that as a new entry. So when we are sure that we have enough items in our inventory to do at least this part of the crafting recipe, we're going to be putting that into a temporary holding map, just so that if we need to backtrack and we need to like refund those items because later down the line it turns out, hey, actually we can't really do that, we can just add those items back in. Speaking of which, let's just do that. So if we go through any part of this for each loop and we query the inventory and we figure out, hey, actually, slight issue, this returns false. That's not exactly what we want. Then we're going to put in some other code. This is going to be a little bit of a mess here for a moment. After the series is done, I'm going to clean up all of this just like I did with the first part of the inventory series, comment everything nicely and upload it to the Patreon page and for YouTube members as well, so that you can download it. For now, it's all going to be a little bit messy. The final project is going to be a lot more clean. Anyway, pulling off of this false node, what we're going to do is we need to check then the items that we have used. And we're effectively going to do the same thing here. So we're going to get the keys from the items that we've used. And we're going to be using that for a for each loop. And this is just as easily as, hey, we've removed them from the inventory, so we don't need to be doing any checking on whether or not they can fit back into the inventory, because there's literally no way to remove them, do something else, and then have them returned, because this is all going to happen in a split second, in like an instant, within a frame. So we simply just say, hey, everything that we just removed, I'm deeply sorry about that. We're going to just add them back in. So we'll just add item, and the item to add, we'll just do that. And we will do that in a for loop again, a normal for loop, not a for each loop. For each loop is the default one that it selects, but you want to do a normal for loop. First index will be 1, and the last index will be our items used once again, and we're going to be finding the corresponding item, and that will then be the last index. So that's going to be adding in the amounts that we removed to begin with, and that'll be in the loop body for that. And it's going to be doing that for every single item that we just removed. And after we have done that, we do another early return, because we didn't have enough items to craft after all, and we don't want to move over the rest of all of this. So again, when we early return, it also aborts whatever we are doing within this loop. And that is important, because that means that it's not going to run whatever code we put into this completed section. So if it manages to remove all the items, it means that it's found all the items. There's enough of all the items, because this never ran. So on this completed, we're finally going to be adding the new item to our inventory, which is effectively just kind of the same thing that we're doing here. So we will, from our crafting recipe, which we can copy from any random place, because again, it is just the input parameter here, we're going to get the resulting items. And you'll not be surprised to say that we're going to be using the keys for that. We're going to be putting that into a for each loop. And then honestly, we're just kind of going to copy this, which is the for loop, the add item, and the finding node, because it's exactly the same thing. We'll use the finding from the recipe resulting items. The array element is going to go into that finding node as well. And then the array element is going to go into the add item function. And that is effectively the crafting system all working and set up. So again, there's quite a lot going on with all the noodles going all over the place here. I am going to clean this up so that everything is a little bit more readable. And now let's actually add in some debugging information as well, because we have got a couple of early returns here that might not fully make sense to you. So if it doesn't work, what you want to do is you want to add in a new string, and we'll just call that a debug string. Now, every single one of these return nodes has this little string in it. So we can see, hey, there's not enough inventory space, so not enough space. And then this one is a early return for one of the items was lacking. And then I guess at the very end here, what we can do is we can also return, and this one will just be crafted. But for now, let's just go ahead and test this. I think the easiest way to set this up is just going into blueprints, into my third-person blueprint, and just add a quick little debug key. So let's add a debug key F. And what we'll do is we'll get the normal inventory component. It should be noted that because this is all done through the inventory component itself, it will not take into account multiple inventory components. So if you have something in your hotbar, or eventually maybe if we go into an equipment system, into like your equipment inventory, it's not going to sample that, and it's not going to be able to see that and use that in crafting. I think that is probably desired behavior. It not yanking it out of your inventory for like your hotbar or your equipment. If you do want that, you can probably figure out how to do that on your own. It's just a matter of creating something that takes in an array of inventory components and then querying all the inventory components there, which is effectively the same thing that we did in the inventory query video at the end there. Anyway, so let's try to craft an item. We're going to be trying to find a recipe here. So we can actually, and this is quite fun, we can just make up a recipe on the go as well. We don't need to only use recipes that exist in that data table, because we can just literally like make a map, and there we can see, okay, we want to create a thing here where we take in the health potion. Like we need 10 health potions for this. This is not going to be stored anywhere. This is just literally a one-off recipe that you can make. So maybe if you have like a specific crafting station that crafts a specific type of weapon that takes a specific thing in, and you really don't want to just deal with having that in your data table for whatever reason, you can still do it this way. But we're going to be doing this with a data table because it's just the way that makes the most sense. So we get the data table row, And there we can just get in a data table, which will be our data table for crafting. And that'll just have your drop down of all the rows in there. And it'll just be our damage potion. If it can find that row, we'll go into craft the item and it will be able to find the row because, again, it's just through a drop down. The out row will go into the recipe. And yeah, that's pretty much all there is to now crafting items. And now that we have that, we can, after the actual crafting, we can add a print string and just print the debug out string that we had there. So now we can like pick up these potions from there. Those are potions because I don't have a model for them. I picked up a sword as well because why not? Let's pick up some of the rocks from this chest. And now if I press the I key to open the inventory, I think we should be able to craft even with the inventory open. And there we go. We removed 5 of the rocks. We removed 1 of the potion and we got 1 of this potion. So now if we try that again, we should get a second potion. And if we try it again, nothing will happen and it says 1 of the items was lacking. There is an issue here with attempting to access a index out of range. And that is because we are trying to remove an item multiple times in a row there. And it doesn't really hinder functionality, but it's a thing that we probably should take care of anyway. So in the remove item functionality, what we're going to do is we're going to check, hey, the inventory array here, we're going to check if whatever we find is a valid index. I'm going to be putting that into a branching node. So if it is a valid index, we'll just move on with the rest of this function. But if it is not, we won't be doing anything. And then the index that we get is the index that we find. If it doesn't find anything from your inventory component with the item that you supply in, the index that it will give is -1 because that's an index that is never possible to get. So it's not accidentally going to access something that it's not supposed to. But it will sometimes result in that weird error that we saw a moment ago. And actually, while we're at it, we kind of over-engineered this little bit that we have here. Because since this is a decrementer anyway, we don't actually need to set the value of it afterward again. Because it's decrementing a reference. So we can just do that all immediately like that. And that will also improve any potential errors that you might be having. So now with all that, if we just pick up those potions again, we pick up the rocks from here. I open the inventory and I press the F key. You see no more errors, but the functionality still fully works and we can't craft more than we have the items for. So technically speaking, we have a crafting system. We have no way to interface with it yet, but that's going to be a thing that we do next time. We're going to be making a crafting menu. We're going to take everything in our crafting data table and we're going to be putting it into a crafting menu. Man, last time we set up the entire code for the crafting system and that was a big video. Today we're going to be making a UI to take advantage of that code because right now we just have a debug key to test out whether or not the crafting works, which luckily it does, but that's not how you want to play the game, obviously. So let's take a look at all that. We're going to go into the inventory folder here and I'm going to make a new user widget, which will be a widget blueprint, and we'll just use a widget that's called as WBP crafting interface or something like that. And to that, we'll add a canvas panel. And this is going to be where we add in everything in a moment. But before we do that, I want to add in a other user widget here. And that's going to be the WBP crafting entry. So we're going to be making this thing here, which will be a... we'll make it a size box. I like using size boxes for things. And we'll probably set a width override and height override here. Change this thing to desired on screen so that we can see what the actual dimensions of it are going to be. And then let's set these to, I don't know, 200 wide, maybe 300 wide and 150 tall, something like that. Those can be pretty nice looking buttons, I would say. Speaking of buttons, I think what we'll want to do is we'll want to be adding a button to this size box so that we can actually click it when we are ready to do that. And then I'm going to add a vertical box to this as well. We're going to actually be adding 2 vertical boxes. One that's going to be outlined to the left and the top. And then this will be the recipe that'll be displayed. And then we'll actually wrap that in a overlay so that we can have 2 of them. And we'll add in the second one here, and that will be the items. And that'll be outlined to the right side and the top as well. And now we're going to get a step deeper again. We're going to be making yet another widget blueprint, and this will be the item display. And what this is going to be is it's going to just be a horizontal box with in it one image and one text. And this might look a little weird, but if we just set this to desired on screen, it makes a lot more sense. Let's put in a little bit of padding to the right side of the image here, like 50 is a little much, maybe even like 20, so there's a little bit of room in between. Let's actually go down to 10. Now we need to take in an image, the name of the item, and the amount of the item that we want to display here, because we're going to be adding multiple of these to both of these, and then we're going to be adding multiple of these to this, so that's going to be fun. So let's get started with the item display. Let's make sure that both of these elements are set to is variable, and then go into the event graph. And that way on event pre-construct, event construct, doesn't really matter which one we use, we can set these up. So let's add in a variable here for the recipe that we're going to be displaying. And if you've been keeping up with everything that we've been doing so far, you know that we have a struct specifically for crafting recipes now. So let's set up those values. First and foremost, we need the image. So we'll call that icon, and that will be just an image. Doesn't really matter what type of image it is, just an image. We're going to expose that, make it instance editable, and then we're going to also expose it on spawn. And we'll do that with a couple more variables here. So we'll need the icon, we'll need the name, which is of course going to be a string variable, and then we will also need the amount, which will be a integer. And with that, we have everything we need. So the image is pretty easy to set up. It's just the image, set brush from texture, and the texture actually needs to be a texture 2D. So let's set this up as a texture 2D, and then we can just put the icon right into there, and that's kind of all there is to that. Then for the text block, we're going to set the text in the text block, and we'll get the name of the item, and to that we're going to be appending a space, an X, and a space. This is just for like a multiplication sign, just this amount. Actually, let's get rid of that last space, and then we'll get the amount, and we'll put that in there, and that'll make a string that has the name, a space, and then the amount that we need, and that's going to be how we set the text. This is all there is to this little element of the UI. So this now by default says times 0. We also probably want the text here to be aligned to the left, so that the amount of items as it grows to the right. And with all that done, let's go back to the crafting button itself, because now we need to go into the recipe and the resulting items and show those, so we actually know in the gameplay what we need to craft it. So let's make sure that both of those are variables, and then go into the graph. So this crafting button will need a recipe, and we'll call that supplied recipe because we already have a variable called recipe here. That will be of type recipe, the struct that we made for it. And with that, we're going to, on pre-construct, let's get the supplied recipe, split the structure pin, and then for the items that we need, we're going to be adding stuff to this based on that map. So we've done this a lot. We'll get the keys from that map, and then we'll do a for each loop over those keys. And for each one of those keys, what we're going to be doing is we're going to be creating a new widget. And the widget that we'll create will be one of the item displays, which takes in an icon, a name, and an amount. And wouldn't you know it, this thing actually has all that information in it. So we can get the item, and from that we can get the item name, and we can get the icon. And we can just supply those in straight up, nothing more to it than that. For the amount, what we'll do is we'll get the recipe, and we will just find the item that we're currently working with, and we supply that in. And that creates the recipe. And after we've created that display widget, what we'll do is we'll get a reference to the recipe box, which is again the box that's going to be over the left hand side, and we'll just add a child to that, and the child will be the widget that we just created. So it's going to be stacking those up in that horizontal box or that vertical box. And for the items, so that's the output items, we're going to be kind of just doing the exact same thing. So we'll just kind of like do this and complete it. We'll just get the keys from the resulting items and then put that into its own for each loop, where we're going to hook up the array elements here to all these things. And then we also need to hook up the map reference to the resulting items. So supplied recipe resulting items. And then we kind of just add the loop body, creates a display widget. And then we're going to be adding that instead of to the recipe box, we're going to be adding that to the resulting items box. And that's everything there is to it for the actual item button. Let's do a little test here and make our supplied recipe. We can just make a mock recipe here for the default values. So we can set the recipe to take in a damage potion, let's say 5 of them, and then like a sword, 3 of them, and that will give us back a rock, 2 rocks, and then maybe like 1 health potion or something like that. Just as like a mock-up, so that we have that. Because it is an event pre-construct, it's going to show it in the design time as well. And there definitely is just a little bit too little room for this. So let's make this a lot wider. Let's make this 700 units wide. Let's start with that. See if that is enough. And then make sure that the overlay is actually set to being horizontal and vertical. And then the recipe will be here over on the left side, and the resulting items will be over on the right side. And everything just works like a charm. And we can keep those default values just for troubleshooting purposes for the time being. And that almost makes this functional now. So we're going to go one step up again. We're going to go back into the crafting interface, where we're going to be adding in another vertical box. And we're going to be adding that here to be like outlined to like slightly more than the middle, I guess. And we're going to be, I don't know, just shaping it like this. Just something weird. You could just add this to the inventory screen itself, I realize now. Maybe. That would be kind of nice. That would be kind of nice, wouldn't it? Let's take a look at that. Because we have plenty of room here to add other things. So, yes, actually, let's do that. Let's add a vertical box here instead. And we'll just line that up with this item grid and make it something like this. And then we'll outline this to something like that. Make it scale up properly. And all that we're going to do is we're going to take this vertical box, make sure that it's variable. And then on event pre-construct, we'll get the data table row names, like all of them. And we will add in a data table for crafting. So that's going to be all the items that we have are craftable. And we'll get data table row, just the normal one. And that's going to take in the same data table. So that's crafting. And we'll just, with all of out names from the get data table row names, go through a for each loop where we just add every single one of those. So we just put that in there, that in there. And then if that row is found, we will create a widget. The widget we'll create will be our crafting entry. We don't actually need the crafting interface anymore because I've decided to just implement that in the normal inventory screen now. So we can delete that. And then once it's been created, much like before, we're just going to get this vertical box and we're going to add a child to it. And the child we add is the crafting widget entry. Now, there's one last thing that we do need to make sure that we do, and that is actually supplying this thing with the recipe that is going to be crafted. So that's actually quite easy to do. Going back into the crafting entry, we simply just go supplied recipe. We make it instance editable and expose it on spawn. Kind of just forgot to do that, to be honest with you. And then we can come back into the player inventory and just refresh this node, and it now has this, and that just hooks up simply like that. And if we look at that, we now see, hey, we have one crafting recipe that we can do, and it is for our health potion, or it's still called a health potion. Of course, it's supposed to be called a damage potion, and this will now scale up easily, properly, like left to right, so we can say, this is actually all that we need as far as inventory real estate goes, so that's quite nice. And now it'll be as easy as just opening up this data table, adding in a new row and saying, okay, we want to make a recipe that takes in something like 15 rocks and gets us a basic sword, just one of them. And now that we have all that, if we go back into the player inventory and we recompile this, bam, we have our new recipe right there, ready to go. Now, they are really on top of each other, so what we might want to do is go back into our crafting entry real quick and just go back into the size box, selecting our button, and setting the padding for the top and the bottom to like 10, so that there's a little bit of room in between each one of them. Just makes it look a little bit neater. Maybe 10 is even a little too much, to be honest with you. With all that, we can now finally start making these things clickable. So in the crafting entry, we have our button. We can just simply put an on-clicked, and then we need a reference to the player's inventory that is going to be doing the crafting. For the sake of flexibility, what we're going to do is we're going to give the crafting entries a reference to the player inventory widget instead of just directly to the player inventory's components, because that way if we at some point just decide, hey, this player inventory widget needs to display the inventory of something else, it's also going to be sampling that other inventory for the crafting system. So that way they always refer to the exact same inventory components. I don't see a lot of reason that you would change, like on a whim, what inventory components the WBP inventory player would show. But if you do, at least things will be consistent. So it's actually really easy to set up. We can just add a variable, and that will be player inventory screen or something like that. And that will be of type WBP player inventory. And we'll make that instance editable and expose it on spawn, as we do so often. Then we can go back into the player inventory, the widget that is. We can refresh this node, and then it wants a player inventory screen, and we can just give that a reference to self, because this is a player inventory screen. And now that we have that, when we click this, we can use that to get the player inventory, and then we can use that to craft an item. And the item that we'll be crafting will be the recipe that this very thing shows us. And just for shits and giggles, let's put in that print string again so that we can troubleshoot anything if anything goes wrong, but everything should be going fine now. So if we start up the game and I open up the inventory, they are overlapping a little bit, but you can see that we have our little buttons here, and we can click them, and it says one of the items was lacking because we literally don't have anything in our inventory, of course. But if we then take like some of these rocks out of here, and we take this sword, now we have literally every item in the map. We open this up. We can see there's a slight issue with it re-adding the old everything a second time. We'll take care of that in a moment, but for now, if we try to make a damage potion, it will just make our damage potion the way we were doing before. We can do that again, and we can use our new recipe easily to make a sword. So it takes in 5 of this slot, and then 5 of this slot. Maybe there was like 10 of this slot and 5 of this slot actually, and gives us a sword. And that's now just like that's in our inventory. Okay. This is a little bit of an issue because every time we open the inventory now, we're going to be adding more and more and more stuff to this, and obviously that's not what we want. That's easy enough to set up. We can just go vertical box at the very start here on event pre-construct. We can just clear children. That's something that you'll just sometimes need to do with these kind of things, and that's easy enough. And now that I think about it, we'll probably want to wrap this in a scroll box as well, because we're going to be having at some point a lot of these, I imagine. And now every time we open this, it's not going to be stacking up billions of different buttons, which is quite nice. Now let's actually do the anchoring for this one properly as well, so that they don't overlap anymore. I'm just going to give this one a little bit of extra room through that side, and then give this one a little bit of extra room through that side. Just a bit of a sneaky way to make sure that they don't actually end up overlapping. And now they look pretty good in the full screen view. And in this weird aspect ratio view, they also don't overlap. So that's good. Maybe this one could stand to be a little wider though. I'll just make it a little wider in general. But that's just going to be a thing when you have a very square aspect ratio. These things are going to be overlapping. Here in the size box, in the crafting entry, we can set the minimum desired width. And we can just say the width override here. Let's say that's 600. I like the look of 700 more. But let's say 650 will be the minimum. So now these buttons will never be less than 650 pixels wide. So even in this, you can see they don't start like squashing up over each other. And that's kind of that. Now that we're reworking all this anyway, we might as well like pull these two like up a little bit into there. The hotbar is going to be down here, and eventually an equipment thing is probably going to be up there. And now we have like scrolling, which is also going to be scrolling through this. That's just kind of something that we have to deal with. And if we add in like a bunch more crafting recipes, so we can just kind of like honestly add in a couple of empty ones because it's not going to be doing anything. But we'll add in some more buttons here for us. And you can see that we can scroll through these as well. So now we have an interface to be doing our crafting with as well, which obviously is much preferable to having it the way it was before. And as a last little thing, if you are running into an issue where you're like, actually I want to have like 5 different inputs for a recipe, and then it's doing something weird, where, for instance, I like have things going outside of the actual button. Also, I added some text here for intake and output. You can figure that out on your own. The issue there would be that your size box has a height override, which is going to just make it always be that height. So what you want to do instead is you want to do the minimum desired height to that. When you do that, it can still grow larger if it needs to. But it's always going to then take that as its minimum. So I am personally quite used to spamming the overrides, but you shouldn't do that too much. You should be using the minimum desired instead. Now that we have a crafting system in place, we finally really should be looking into having equipment for the player as well. As a fair warning, while a lot of the code that we have set up for this entire system has been fairly modular and reusable in a lot of places to scale things up, this is going to be a little bit more hard-coded, and that is because it's going to be for the player equipment or character equipment, and by and large, I don't think you're going to need a lot of flexibility in that. You set that up once and then it just kind of works, right? So no use in overcomplicating things too much. What we're going to do is, first and foremost, I am going to go in my inventory component and we're going to make a child of that. And that child is going to be the equipment component. And the reason that we do that is fairly simply because we're going to add a couple of like getting functions to get the stats from those equipment items. We're not actually going to be doing anything very special with this. We're just going to be treating mostly the equipment thing as just another inventory component, which brings me to my third-person character, Blueprint, here. And we're going to open that up and just add another component. And this time we'll add an equipment component, which again is just going to function as yet another inventory component. There is a argument to be made here that if we go into the equipment component itself and we select class defaults, we can see the inventory size. You probably want to set this to only having as many slots as you have equipment things. So that will be a helmet, chest plates, like leggings, boots, maybe gloves, and then a shield and a sword, for instance. So that would be 7 inventory slots is what we want for this one. And as you can tell, the equipment is just going to exist in normal inventory slots. We're not going to make special slots for those, which we put those in, because that would require a lot of reworking and adding on top and adding new code. And that's generally not really worth it. So we're just going to reuse the existing inventory functionality, and we're just going to kind of have to remember that inventory slot 0 is the helmet, and then 1 is the chest plate, and then 2 will be the legs, and then 3 will be the boots, 4 will be the gloves, and or 5 or whatever, and so on and so forth. That's just the easiest way that we're going to go about doing this. All that said, let's go into our player inventory screen and add in our equipment here. So if we can find the player inventory, there we go. We already have the crafting system in there as well. And we're going to be adding some more now. So let's put this into the overlay. And we're going to put that overlay on the right-hand side of the screen. You might want to swap this around with the crafting, having them crafting all the way to the right instead. That's entirely up to you. You could, of course, make this all into separate screens as well if you prefer. I like having everything just on one screen available for us. And then we're going to be putting in our item slots. So we put in just loose item slots. We're not going to be putting in like an item array or an item grid or whatever, because that will just add them in a grid. And we want these to be a little bit more special. So the way we're going to do this is we're just going to add like 7 of them. So that's 1, 2, 3, 4, 5, 6, 7. All of them are on top of each other. And let's give them names. So this is the helmets slots, chest slots, legs slots, boots slots, gloves slots, weapon slots, and then we also have the shield slots. And if you have any other things like maybe other types of accessories like rings or necklaces or whatever else, of course you can add as many of these as you need. And then we just kind of position these in a way that makes sense. So this will be outlined to the middle and then have maybe a little bit of padding to the top. And really, I think all of them are going to be outlined to the middle. So let's stick with that. And then the chest will have a little bit more padding to the top. So let's say that's 150 or something. And then the legs will be about 300 padded from the top. And the boots will be even more. So let's say that is 450. And then the gloves will probably like put next to the boots or something. I'm just kind of going off the item layout that you have in a game like RuneScape, right? So we'll put this also at 450 from the top, and then padding to the right will be like 150, so that it ends up over there. Then the weapon slots will be, this is like 10, 150, so that probably will be like 200 from the top, something like that. Maybe like 250, 220. 220 seems good. And then 150 to the right. And then the shield slot will put in, I think we said 220 from the top, right? Yep. And then 150 to the left. So now we have this overlay here that we can move around as one whole thing fairly easily. We can like resize it quite easily as well. At some point, of course, you resize this thing out of existence, so there's that. Not much you can do about that. And actually, let's maybe like put this down lower a little bit. We can make it a little bit more thin, and realistically you can put this wherever you want. Anyway, for now, this is what we're going to be doing with this, and we want to make sure that all of these item slots are also marked as is variable, which they are. So now if we go over into the event graph, we need to set the inventory component for all of them. Since they don't exist in an item grid, some of the things that the item grid does for us, we need to manually set up. So we kind of just get all of these. So all of the equipment slots that we have made, we just get references to them from our variable stack. And then we can fairly easily just make an array out of them, just to keep things a little bit more clean. And then we can use a for each loop to set the inventory component that these are aligned to. We don't need that last one. Do make sure that we actually set these up in the order though that we want, because I just put them in randomly now. We don't actually want to do that. I wanted to have helmet slot at 0, and then I wanted to have the chest slots at 1, so that makes sense. And then I wanted to have the legs slots in 2, the boots in 3, the gloves in 4, the weapon in 5, and the shield in 6. So let's rearrange those real quick, because we're going to loop through this, a for each loop. So it's going to iterate over these in the order that they exist in the array. Let's do a for each loop. On completed, we'll do just everything else that we usually do. But on startup, what we want to do is loop body. We get the array element and we set the inventory component. And the inventory component will be the equipment inventory from the player. So it'll be a new variable. Let's just copy over the player inventory variable and call it player equipment inventory. And that's just going to be the inventory component for the slots individually. Now, before we forget, we have this thing as instance editable and expose on spawn. So let's go back into the third person character, and somewhere here in the begin play function that we made a while ago, we have the create WBP inventory player widget, which now has the player inventory equipment. So I'll just put our equipment components into that. And there we go. For all intents and purposes, we can just keep this as an inventory component reference. You could specifically make this an equipment component reference as well if you need to access any of that for any reason. We're not going to do that. Now, we want to select all of these slots, and we want to make sure that for all of them, allow drag is set to true. We have that bool on there, whether or not inventory slots are allowed to interface with our drag drop system, which is not really a drag and drop system anymore. It's more like a click and click system. But by default, that's set to false. We just want to make sure that it's set to true for all of them, and now it is. There still is a couple of issues though, and that is if we pick up some items, we can put in any item that we want, and it probably won't actually display very well. You see, it just kind of disappears. They are in this inventory component now, but since this isn't part of a inventory grid, it doesn't refresh all of these slots anytime the inventory component changes, which is a little bit annoying. And we can't even take things out because technically speaking, the slots themselves don't know that they have anything in them either. So there's a little bit of extra work that we need to do to get these individual slots working out just like they would with a normal inventory component here. But luckily, it's not that difficult. we need to set up a couple of things in the actual item slots blueprint that we have here. So you will remember that we have the on preview mouse button down, which was really quite big. Some of this probably could do with being collapsed into its own functions, to be very frank with you. I also remember that we have this on drag detected and on drop detected, which I never removed. We're not using that anymore, so we can just remove those. Same in the event graph, we have this like wait for drop operation, which is part of the old system. We don't use that anymore, we can just get rid of it. And just to prove to you that that didn't actually break anything, we can pick up some items, and our normal inventory system still works perfectly fine. Anyway, back on mouse preview button down, we need to add in a couple of more things. The item slot itself is going to have a concept of being able to filter an item. So we're going to set this as a class filter, and the class filter is going to be of type BP item, and it will be a class reference. So this way we can say, hey, only weapons are allowed in this slot, and only helmets are allowed in this slot. And that way, if you, for instance, have a door in one of your levels that needs a key in it, you can give it a little interface and set that specific item slot to only take in a item of the type class key. So it is actually very expandable as a result of that anyway. We do want to expose that, obviously. And let's just drag this in here, and we'll make this a equal. And we'll also check if this is a valid class. So if we put a AND boolean between those, it's going to be checking both of them, and then we can just select whatever class we need here. So we'll just collapse that quickly into a function, check class filter, and that function will mark that as pure because we don't need any execution here. And we will take the selected class from the equals comparison thing, make that an input, and call it class filter. And then we will add a return node, which will just hook up directly, and that will return the output of this AND. And then we'll also put in just the valid class in and of itself as an output. And we'll call this one a has filter, and this one matching filter, which I suppose means that we don't need this AND boolean actually. We just need to check whether or not they match. And that gives us this handy little function here, which we can put in any class that we want whatsoever. We actually probably want to set that to only taking in BP item classes, specifically a class reference, so that we can't put in any other objects like other actors or other assets or whatever. Just makes the drop-down menu a little bit more useful. As you can see, now it only gives you the items, so we can put in any class that we want, and it's going to tell us, hey, do we have a filter to begin with? And do we have a matching input to the filter that we're looking for? And the way we're going to be using that is after our drag drop operation, and we have our drag drop item slot, we check whether or not that is valid. If it is valid, we get the inventories out of that drag and drop operation. We split that structure pin open, and then we get that item asset, and we try to get the class from that. And this is going to allow us to filter on the input class. So first and foremost, I want to check whether or not we have a class filter to begin with, because if we don't, we can just move right onto the pre-existing code without any trouble, because obviously that means that we just have a normal inventory slot. But if we do have a filter, we want to check whether or not the filter that we have is matching with our inputs. Because if it is not, we don't want to do anything. We just don't hook anything up to this false node. If it is true, however, then we also do the rest of our stuff. And now we can go back into our inventory here and start putting in our class filters. I don't have class filters at the moment, or different like classes for specifically helmets and specifically chest plates, but you can easily make those. For now, let's just put in a filter here on the weapon. And that doesn't quite fix all of our issues, but it does allow us now to filter on specific classes. So you will note that if I pick up the potion, I can't actually interact with the item slot that has a class filter on it, but these ones who don't have a class filter on it still just kind of make it disappear. We'll worry about that in a moment. But if I pick up the sword, which is a weapon, it will disappear into this slot. So it is actively and correctly filtering on the items class. And luckily, everything else that we need to do is fairly easy. So let's go back into the event graph for the item slot itself. And we have this pre-construct thing, which just kind of sets up all of the visual information for our inventory slot. We're just going to add a custom event, and we're going to call that redraw item slots and plug that into the exact same stuff. That way we can call all of this functionality again whenever we want to. And now we just need to go down a couple of these branches and add that redraw item slot, as well as manually setting the value of the inventory slots. And then we have a functioning system. So the first branch that we need to go down is in here. We check if the inventory slot already has an item. If that is not true, we're clicking on an empty inventory slot, and we simply just need to put a new item in that existing stack. The code that exists here, we can just keep that going. The only thing we need to do is we need to get the inventory slots struct that we have here, and we need to set it to the same value that we put into the put in new item stack function that we have here, so that the inventory slot itself is also aware of it having been updated, because it's going to have the inventory components be updated. But since this thing is not related to an item grid that automatically redraws itself whenever there's an update to the inventory, we need to manually set the inventory slot itself to have new information, and then also manually say we want to redraw this item slot. And this will now allow us to actually fully be interactable with the weapon slots in the most easy way. So we can actually put it into the weapon slot here, and we can actually take it out. You will note that taking it out doesn't actually take it out yet. So we have infinite sword now. There's a little bit more work to be done there. But we can put things into the slot now. And again, these ones don't have any filters, so you can put anything into them at all. And these are now just item duplication slots. So let's take care of that. The next branch that we can go down is if there is already an item in this slot, right? Then the next thing we check is whether or not that item is the same item as the item that we're trying to put into it. If it is, it's going to try to merge these stacks, but since that the equipment is likely always going to be unstackable, this will always return as not being successful. So the inventory slot that we're working with still will have an item, and it will just like redraw its item. So we don't really need to do anything up in this branch. But if that is not true, you want to swap around the two items. So we do actually need to change some things in here. We have our inventory slot that's going to be set to a temporary holding storage for that inventory slot while we swap the items around. Then we run the put in new inventory stack. And then before we set the temporary item back to the inventory slot in the drag drop item, what we want to do is we want to set the inventory slot in the event graph directly, because this is going to be the inventory slot of the thing that we just clicked on. And that is once again going to get the value of our player character drag drop slots, inventory slots. The new one that we make from that, we're going to put into the inventory slot of the thing that we just clicked on. And then at the very end here, we will redraw the item slots. And then in the very last branch that we have here, we want to go back a little bit more. And that is all the way back to this is valid check. And our left mouse button is true. You could also put this into the right mouse button if you wanted to, but we're not going to for now. That means that we're clicking on an empty inventory slot, which means that we're taking the inventory out of that slot to put it somewhere else. So at the very end here, we simply just put a inventory slot setting node, leave it empty so that it creates an entirely empty inventory slot. And then as with the other ones as well, we redraw the item slots. Again, if you wanted to, you very much could also do that here. If you want to have filterable slots that also allow for stackable items in it, that might complicate things up here a little bit as well. I haven't actually tried that because I'm doing this for a equipment system, which means that for the most part, I'm just assuming that whatever you're going to be filtering on is not going to be stackable. So we just kind of don't deal with that. But you very much could also, at the very end here, add in a inventory slot setting, and we'd set that to something here. So we would make a new inventory slot based on the old values here, so we can just put the has items through, and then the stack size would be the stack size minus the amount that we subtracted. The item would be the same, and the index would still be the same. You could set that this way, and then at the very end here, as always, manually redraw the item slots. In theory, that should work fairly fine now. We can test that in a moment, I suppose. Let's just say that our helmet slot is going to be filtering on our consumable class so that we can test that as well. This is going to be live testing because I have not tried this before, but we can pick up both of these potions and then the sword. And first and foremost, the sword, we can put it in and pull it back out. And then we can put this in the head slot. And in theory, we should be able to put one and one out of that. So that just straight up works. These ones don't seem to be showing the stack size in them though, which might be due to the fact that in the third person character, we needed to get the equipment component and also construct the inventory through a function. I don't actually know why we don't just do that within the inventory itself directly, but we might as well just move some of this stuff a little bit to the right. We only ever set the text number to being invisible, and we never seem to set it back to becoming visible, strangely enough. So we probably should have put that in somewhere earlier. In this case, I guess it doesn't really matter for the normal inventory system because it redraws all the inventory slots anyway, like from scratch. But now that we're redrawing existing inventory slots, I guess it does make a difference. So if you do want the stack size to show in your equipment slots as well, that is the way that you fix that. You can see I have one sword in here and 2 potions in there. Especially if you have like an equipment slot for potions, right? That might be quite relevant. And you can of course set this on a per thing basis. So you can like put this into a branch with a bool, whether or not it should show the numbers for these individual slots. I guess for now we actually might as well implement that. It's not that difficult. We do a branch, we do a promote to variable, show item numbers, expose that. If true, we do that. If false, we just move on. It's just as easy as that, really. We compile, we make sure that the default value would be true. And then for all of these, I will select them and set that to false. So now at this point, it would just be a matter of going into my items and getting my armor class, for instance, and making child classes of this. So let's say we have armor helmets, and we can just make siblings of those by just copying helmets. And then we have chest plates, we'll have legs, we'll have boots, we'll have gloves, and we'll have a shield, which I also just make armor. If you have something like dual wielded weapons, you might want to upgrade this filtering system to allow in a array of filters to check, hey, if it is part of one of these. And then you can also like make an offhand weapon. Maybe instead you can make your shield class take in a damage value as well, so that the offhand weapons are technically just still shields that give you an attack bonus, something like that. But now that we have all these in place, we can fairly easily say, hey, this one only takes in helmets, this one only takes in chest plates, this one only takes in legs, this one only takes in boots, this one only takes in gloves, and this one will only take in a shield. And I'll go into the item assets. I'll just make a like second sword here real quick with a different icon. So the icon for this different sword will just be this temporary one, just to show you that the swapping of items also works, because we haven't really highlighted that yet. So copy over this world item, we'll make this sword 2, and I'll pick both of them up and I'll just swap them around in the inventory slot to show you. And then we'll have a working equipment system. So we can put this into there, and then we can just swap them around easily like that. And of course, this can go into none of these slots because they are being filtered on a class basis. So congratulations, we have an equipment system. Now, you can, of course, then go into your equipment components and make a function, something like get armor stats, and there we can get the inventory array, for which we can do a for each loop, of course. And then in the array elements, we'll break that. We'll check if the item is a cast to armor. And we can then also, if we wanted to, make one specifically for boots, specifically for chestplate, and so on and so forth. For this one, we'll just check all of the armors, make a local variable, total defense, something like that, make that a float. Total defense will be set to our defense, plus a defense from the item that we're looking at. And if we run into any items that are not armor, it's just not going to succeed with this cast, so this won't ever happen. And then at the very end, we can simply return the defense that we have in total. And that's a very easy thing that we can now do on our equipment components to just get the entire set of armor stats. And if you have multiple things that are relevant, you can just make it into a struct. And at this point, we're getting into it. Really depends on the game you're making, what you want to do with this. But we have an equipment system now. So we're getting very close to having, I think, a completed inventory system, at least a completed part 2 of this series. Maybe at some point we'll do a even deeper dive with more advanced stuff. But we're going to be dealing with metadata soon, and then we're going to be dealing with saving your inventory, because that's quite an important thing. And that is going to be it for now, though. So I will see you all back with the next video in this series. And if you want to have the project files, the one that I'm working on right now, or the completed one with everything implemented and things being a little bit more organized and commented and stuff like that, there's a link down below in the description to the Patreon and for YouTube members to download the project files. All right, I would argue that among maybe the crafting system and having like those buttons driven by a data table, this whole metadata thing is the reason that I would call this a intermediate to, maybe if you want to be fancy, slightly advanced inventory follow-up course. And that is because it's gonna be a little bit tricky to get into, but we're gonna go through this one step at a time. So what is metadata for the people who might not know? Metadata is data about data. So in this case, our items are the data, and our metadata will be data about those items. So for instance, for a sword, you might have a durability on your weapon. That would be considered metadata. You might have enchantments on your sword. Think about Minecraft. That would be metadata. You could argue that things like the stack size technically could be considered as metadata as well, but since every single slot in our inventory system is going to need to have a stack size to work with anyway, that's just part of the basic inventory slot structure, and we didn't make that as like a separate thing of metadata. Today we're going to be constructing specific metadata objects, and that's going to be a little over-engineered at first, but it will be a more scalable and more manageable way to deal with things as your game grows. So let's just get started with that. We're going to go right into our content folder here. I'm not going to open up anything because we're going to be opening up things when we get to it. And we'll make a new blueprint class. And something that a lot of people actually overlook, including me for the longest time, is that you have these common ones and then you have all classes. Everybody knows that, right? Everything inherits from objects, but people kind of overlook the fact that you can also make your own basic U object. It's called a U object, technically speaking, but just your own basic object. That doesn't need to be any of these other things. So that's what we're going to be doing here today, and this will just be our BP metadata. This is not going to be an actor. This is not even technically like an asset. This is just a... The only thing that really makes this special in any way is that it is a U object, meaning that Unreal's garbage collection system is going to be able to deal with it. And we'll talk a little bit more about the garbage collection system, because you do need to be a little bit mindful with how that works. Since Unreal collects garbage, unused objects, deleted objects by itself, you don't have to do that manually, which is really nice, but you do need to be careful that it doesn't garbage collect this out from under you. In C++, that is a little bit easier to manage because you have more of like fine-grained control over that, but for now, we're just going to deal with that when we come to it. For testing purposes, I'm going to open up this metadata, and you will note that there's actually not that much going on. We don't even have like a begin play, or we don't even have a tick, I don't think, because that is something that exists in the actor itself. Like this has no pre-existing events. This is entirely empty. So we'll only put in a counter or something like that, just for testing purposes. We'll make that an integer, so that we have some metadata to write to and to read from for testing our system. The idea being that if you need specific metadata for a specific type of item, you're going to make a child class of this broad metadata class, which will then allow you to cast to that and get the specific information out of it. Like if a sword has metadata, it can have like a damage boost metadata or an enchantment metadata bit or a durability, but a shield will probably have entirely different metadata. So what you'll do is when you know that you're working with a sword in your code, you will cast the metadata to the sword metadata class. And if you know that you're going to be working with something like a shield or a helmet, or maybe a key, for instance. If you have a key object and you assign metadata to it, you can say, oh, this key specifically links to a specific door. If you know in your code that you're working with a key, the door will be checking for a key item in your inventory. Then it can cast the metadata object on that key to the key metadata object and check, hey, does this key's metadata point specifically to me? Does it allow it to open this specific door? If that doesn't make full sense yet, don't worry about it. We'll just construct this entire thing and it will start making sense eventually. So there's a couple of old places that we're going to go back to add some things about metadata here. And the most important of which is the BP item class itself. We're going to assign every item a metadata class as well. So we'll add a new variable to this and call this metadata class. And that will be of the type metadata. And you'll need to look through here. We have the BP metadata and will be a class reference. And of course, we're going to be exposing that as well. And the default value of this can just be the BP metadata for now. Then we want to open up our inventory components. And we're going to go into the add item function. When we add a new item to a slot, to an empty slot, a new item is getting created. That's where we're going to be constructing our metadata. Because if we already have a slot that is filled with something, we don't need to reconstruct the metadata. We only increase the stack size of the thing that already has metadata on it. This can cause some issues and some conflicts with merging stacks together if the stacks don't have matching metadata. We can take a look into that in a moment. We can set up an interface that checks whether or not two metadata objects have the exact same data in them. And if so, it will allow the merge. If not, it will not allow the merge. We might make a separate video about that after this one though. For now, when we make the new item, we set the new array element. We're going to make a little bit of room here in the blueprint graph. For that, what we'll do is we will construct a new object from class. Be aware that that is not a spawn actor from class that spawns specific actors. This just constructs a object, which is different. And the class that we're going to be constructing, and this is actually quite nice, is going to be the class of the item asset. So we can get the metadata class, and you can dynamically say what type of object you're going to be constructing. So if you say, hey, an item asset for a sword has the metadata class assigned to it for sword metadata, this is going to be constructing a sword metadata object. This is a mistake that I made while initially developing this system, and it's a mistake that I made in the video itself again. You don't want to get the item asset from the breaking of the for each loop. What you want to do is you want to get the item to add and get the class from that one instead. Because obviously the slot that we're trying to place the item into doesn't yet exist. Now, we get to a little bit of a tricky, fucked up little bit, and that is that a object, when constructed, needs to have an outer. And if you hover over it, it says it's the owner of the constructed object. Every object in the game is going to have an owner, something that it belongs to. And you might think, oh, we'll just set that to the inventory that we created in. But that, while it doesn't really matter, it can be kind of tricky to deal with, because once this is set on creation, you can't then afterwards change it. You can reset the outer. The way you would do that is create an entirely new metadata object and assign all the same values to it with a new outer. And that is a little bothersome to deal with. So the easier way to deal with that is just to assign every bit of metadata for every item in your game when it gets constructed just to something that is going to be persistent anyway. So we'll say get player character, because the issue is when the owner of an object disappears, everything that it owns also disappears. So if you set this to a inventory component on a chest, for instance, you take something out of the chest and then you walk away and the chest unloads, suddenly the outer object for your metadata is gone, which means that your item is broken now. So you need this to be something persistent, and your player character is always going to be around. Alternatively, you could do the player controller instead, or even the game mode, or maybe even the game instance. Or you can overcomplicate things and make like entire functions to reconstruct new metadata items when they change inventories and that kind of stuff. Frankly, this whole metadata thing could be a sub-series in and of itself. We're just going to assign it to the player character because frankly, it just kind of works well enough that way. Once it is constructed, what we need to do is we need to set it to the inventory slot as well. So that means that we're going to go into our inventory slot structure, and there will also add a new variable for the metadata, which will be of type BP metadata, obviously. And this is going to be an object reference, not a class reference like we did before. And now that is a slot that we have in here. This is the annoying bit, because now that we've added something to our inventory slot struct, anytime that we're copying over one inventory slot to another inventory slot, we're going to need to go through and copy over the metadata as well. That is partly because we frankly kind of set up a few of those moments a little bit poorly. Could have set that up a little bit more optimized and a little bit more flexible, but that's the world we live in now, so we're going to have to deal with that. And it's also partly just something that we have to do. And then coming up here too, if we're adding items to an item that already exists, we're making this slot and setting array item. I'm trying to do away with the set array elements node where I can. So what we'll do instead is we will get a reference to the index. You can see here, there's the array index. And instead what we'll do is we'll set a member. And the only member that we'll be setting here is the stack size, because that's the only thing that's going to be changing. And the rest of it will be left alone, because otherwise we'd need to like plug in the metadata here as well, and then the items add and all that kind of stuff. And none of that is really necessary, because that's all going to remain the same no matter what. So we can just hook this up into true and then going on and move on with our lives. The only really like big place that we need to worry about that, I think, is in the inventory screen in the item slot itself. That is where we're doing a lot of copying over in the on preview mouse button down, as you can see. So we have, let's just go from top to bottom. Like in some places here, we are making new inventory slots from the existing inventory slots. And if we're just copying over the entire inventory slot into like a temporary holding inventory slot like this, that's not a problem. It's just going to be copying it over. But it's these situations that become a little bit annoying. So because we're taking some of the data from one place and some of the data from the other place, we now need to go over all of these and connect up the proper metadata. So in this case, we're going to be getting the drag drop item slots metadata and putting that into the new one. And then down here, we have the same thing. So again, we have a drag drop item slots and we want to get the metadata from that one. And all the way down here, I think we also do something similar. So we want to set the metadata for both of these make nodes, which are a little bit messy, to be the metadata from the inventory slot itself. And those should be the most important places that we deal with metadata transference between slots. The only other real important place that we deal with that is in the inventory component itself, in the merge stacks. And as I mentioned before, you really want to like check the different stacks here, their metadata, whether or not they match to begin with, because if they don't, you don't want to allow the merging of stacks at all. But that requires a little bit of reworking. So for now, we're going to skip over that, and likely in the next video, we're going to come back to cleaning up some of this metadata stuff. I don't want these metadata videos to be too long because I feel like this is going to be a little bit more complicated than most things as far as metadata goes. So in the function that we have here, we already are setting local variables, so we can just promote the metadata for the target. So this will be target metadata, and we will set that, and we'll add a rerouting node just to make it look good. It's on the bottom. It should really be there, but I can't be bothered right now. And then for this one, might as well do this one properly. We promote this one to a local variable, and this will be the source metadata. And again, we can just make a blueprint interface on one of these to check whether or not it matches the data on the other one. We'll do that later. And then in here, we have a couple of places where we need to like assign some metadata stuff. So if we merge the stacks, we're getting the source metadata and setting that into here. And then the source slots will be set to being entirely empty, so have empty metadata as well. Fill stack and return remainder is the other branch that we have here, in which case we want to supply it back with the target metadata instead. But then the source slots is going to need to be given the source metadata back again as well, which again I'm not really explaining and going over all this in detail because I think we should rework this anyway. The thing is, you don't really need to split up the metadata and check it against each other, because this entire merging thing should only be able to happen if these two are like exactly identical anyway, right? So you really only need to save one of them and just apply that back into both. Or if they are different, not allow any of this to happen. And also we have like a lot of old code here that we don't need to have there anymore. And then we can go on into subtract item. And this is kind of the thing that I was talking about. We didn't set this up fairly well because we're setting the entire array element here. And what we should definitely be doing instead is we should be getting a reference to this index instead. And that just set the members in that slot. And then has item will just manually set to true. The stack size we will get from this value over here. The item assets we'll get from this value over here. The index we will get from this value over here. And then we can just leave the metadata alone. Like this set array element thing forces you to resupply all of the information that exists already. But we don't need to do that. Matter of fact, I think we're just copying over some values here that don't change. Like the item asset, right? We don't actually need to change that, so we can just get rid of that. The index also remains the same. We don't actually need to change that. Has item, also don't need to change that here. We only need to adjust the stack size here. So this is a lot more straightforward doing it this way. And it doesn't create this weird ass stuff where we need to resupply stuff every time we add new information to our struct. Same thing here in the add item to stack function. I'm just going through all the functions and seeing where we have issues. We use this set array element. What we can do instead is we can just use the get reference, provide in the stack index and say set members. And the only member that we need to change here again will be the stack size. So we'll just update the stack size like this. And then we can get rid of all this stuff and not need to worry about all this and the metadata to go with it. Actually, we do need to use this getting node as well. But we don't need to worry about this. And that makes our entire code just a lot more actually user-friendly. So connect everything back up here, put item in new stack. I guess this one can keep being the way it is, that is fine. Split stacks I don't think works right now very well. And that is because we have this slot index that we're getting. I guess here, because we're splitting stacks, both of them are going to have the same metadata anyway. So anywhere we have a make node, we just provide in the metadata from the breaking node. That's just quite easy that way. Of course, in the inventory constructor itself, we don't need to provide in metadata because this just makes an empty inventory. Swap slots deals with entire slots and not broken down slots. So that's actually fairly easy. Clear inventory slot obviously just clears an inventory slot, only keeping the index around, so that makes sense. And that's everything that is to do with metadata. So we now have this stuff all set up to work, and the system is updated to deal with metadata. Now let's actually show you how that works and that it works and all that good stuff. So first and foremost, we cannot do this anymore, where we have an inventory component that just has like pre-existing items on it, because these won't have metadata created for them, which is a little bit annoying. So if we go into the inventory component here and we go into the construct inventory, we can still do this. We just need to save this inventory component that we had to begin with, promote it to a local variable. This will be the storage before it actually gets cleared out into being entirely empty. And then after we've constructed the entire inventory altogether, we'll do another for each loop, and that will just go over the temporary storage of the inventory. And there we can just simply like break inventory, and we will just check, hey, any items that were in the inventory before, let's re-add them. So we add item, and the item to add will be the item that we have in there. And we will, of course, do that in a normal for loop. We go from 1 to the stack size. And that will then re-add the items that we put in there in the editor, but now with metadata. And of course, you do want to construct that inventory before you create the widgets, because the widget is going to be taking in the constructed inventory. And now we'll be able to see that if we open up this chest, it has the 40 rocks in it that we had in there always, but not in 2 stacks of 20, because rocks only are allowed to stack up to 10. So it's actually adding them in the way that they should be added in, so they don't have any like stacking overflow type of stuff going on anymore. So now everything works fine. Now the last place that we probably need to change this metadata thing is in the inventory grid here, and that is in our update item grid. When we create a new widget blueprint, you can see that it's created with a empty metadata slot, so that's going to get rid of the metadata. Once we have hooked that up, we can test things out properly. And the way we can test all that stuff out is going into our game and then putting in a console command, and that console command will look something like this. obj list class equals the name of your metadata object dot the name of your metadata object underscore c. The underscore c is just a quirky blueprint thing. And if you run that, you will see in total we have 5 objects now. And that adds up because we have 4 stacks in here, and I also gave myself some rocks apparently on startup. And then if we pick up some more items here, that's 2 more, that's 3, that's 4 more, but those are the same items, so there's only 3 more. So if you run it again, we should see 8 objects now. Now back in our character here, I'm going to add a debug key. I think we still have a debug key left over from our crafting system, which we don't need anymore. And we're going to, when we press the debug key F, we're going to collect garbage. This is just going to force Unreal's garbage collection to run so that we can see whether or not objects are getting garbage collected or not. And then if we press that garbage collection key that we just set up, so F, and we run it again, we still have... Now, there still is a couple of issues with this entire thing, that being, if we split these things up, it doesn't actually make new metadata objects, it just shares the same metadata object. And this is coming down to how references or pointers actually work. When we're splitting things up, we're just setting both of these stacks to reference back to the same metadata object, rather than creating a new one for the newly created stack. So we can see this will still be just 5, even though we have very clearly like 9 different stacks here. And then we can like merge them back together and stuff like that, and it'll always still be fine. So there's a little bit more work to do on this metadata thing, but I think that this video is long enough and large enough as it is. So we have created these metadata objects now, and we have them persisting around, being prevented from being garbage collected when we don't want them to. Obviously, if we end up like deleting any of these items, they won't be referenced any longer, and if we garbage collect them, they will be removed. Which actually brings me to this button. I haven't updated that to use our new system yet, so we just created a mouse button down, and we just get the player character, cast that to our class, get the drag drop item slot variable there, we remove that, and then we set it to null, and that'll just remove the item for us. So now we have a couple more things in our inventory, and I can drag and drop these and remove them. And now if I garbage collect and I run this again, we see we only have 3 objects left, because when the items actually get deleted, the metadata objects are no longer referenced by anything, because they're only referenced by the inventory slots that they exist in. So garbage collection can grab them and reallocate that memory. Next time, we'll fix up a couple of the issues about this, like the splitting, the merging of stacks, and that's going to introduce us to also allowing to read and write from these metadata objects. It's quite an undertaking to set up this metadata, but it is really quite cool. So tune back in then, and for now, hopefully this was kind of manageable to make. Let's keep going with the metadata. Last time we set up the metadata objects to be created. So we have this little thing down here telling us how many metadata objects exist, and they will persist as long as the item slots that they are assigned to persist. But we had the issue that if we split these stacks and we check the metadata again, it's 7 objects because I picked up 2 other objects. That's a bad example. But if I check it again, it's still 7 objects, because what it's doing is both of these stacks are just referring to the same metadata object. The newly created stack isn't getting its own metadata object, which means that even if I were to remove this one would still have a metadata object, but then if somehow the metadata on this one would change, the metadata on this one also changes, which obviously is not exactly what we want. And that is because that is how references work. Because if we have an inventory slot, it has a reference to an object that like physically exists somewhere, not physically in the world, it's not an actor, but we have like this object. And if we split the stack, it's just creating another pointer to that same object. And what we want to have happen is when we split a stack, what it should do instead is it should create a new object that is identical to the one that we have and point to that one instead. Similarly, we can still merge items even though we're not checking if the metadata between the two stacks matches either, which is obviously also an issue. So let's take care of the splitting stacks first, and then we'll go into the merging stacks a little bit after that. We'll go into my blueprint folder here, and I'm going to go into my BPI inventory utils, and I'm going to be adding a new function to this. And this will be copy metadata. And for that, we will take one input parameter, and that will be the metadata object in, which will be a BP metadata. And then we'll also make a metadata output, which will be the metadata object out. And this will be the copy. Now, for every single metadata class that we're going to be making, we need to make an implementation for this, because every single metadata object is going to have different data. So it's going to have different data that it needs to copy over into a new object. That's just kind of the reality of how this is going to work. Actually, now that I'm thinking about it, we don't need the in metadata, because that's just going to be the object that we're implementing this on. So we only need to have the metadata object, let's call it copy instead. Let's go into our BP metadata object, like the parent one that we have over here. And if we go into the class settings, we can say the implemented interfaces, we add one into those, and we'll add in our BPI inventory utils. And if we open this up, we can see the copy metadata. And all that we need to do here really is construct object from class. And in this case, what we can simply do is we can just construct a object of BP metadata. We don't need this to be like dynamic or anything like that. For the outer, we will want to get player character, but we can't do that because, again, this is just a generic object. This is not an actor. It doesn't have access to a bunch of different functions. So what we'll do instead is we'll go back into the inventory utils, and we will make an input here after all. And this will just be we can make this an actor type. Let's just to be sure, so that everything always is going to be the third person character. Player character outer, I'll call it, so that it's clear what we're using it for as well. And that way we can just pull that through. Now, every time we try to copy over some metadata, we do need to provide the player character, but we simply just cannot get the player character from inside here very easily. So that's the way that we go around that. Now that we have this new constructed metadata object, we can set the counter value in it to the counter value of this object. And then if you have other information in here as well, like strings or enums or floats or whatever, you just simply do this for every single value that exists on your metadata object. And once that is done, we just supply that in this. And now we have a function that copies over your metadata object. Now, with this, if you really want to make something that has the outer of your metadata object being the inventory component, rather than it being the player character always, this would also be the way you can do that. You can just make this a normal object input pin, and then you can put in whatever outer you want. And that way you can just copy over into a new metadata object that has a new outer, which might be worth doing. So let's go back into this and just make this a normal object reference anyway. That way it is more flexible to do what you want with it anyway, if you want to do other stuff with it. So, funny story, I just recorded a segment updating the split stack function here. Apparently, we don't even use the split stack function anymore, like at all. So we can just kind of remove that, and that will prevent any confusion in the future. So the way we apparently do it is in just the item slots on mouse preview key down. This bottom branch is just like all that. So we're going to be doing it in here. So when we make this new item drag preview, instead of taking in the metadata from the inventory slot itself, it's going to be copying over that metadata. So we copy metadata with the message, and we put that after the setting of the inventory slots. We get player just to have that context object. And that is then going to be our new metadata object. And that's really all there is to it. Just adding in that one new function is going to make us a copied metadata object. And now we'll be able to see if we go into our list, we have 5 objects. This should be 6, 7, 8, and 9. And now we have 9 metadata objects. So it's creating new objects. If I try to garbage collect, it still has 9 objects because the inventory slots are actually referring to new metadata objects there as well. So it's safe from garbage collection, and we now have actually copied over metadata, which again, we can now in theory use if we wanted to make the outer of every single metadata object refer to the inventory component that they're on. Now, when you transfer them to a new inventory component, we can detect that and copy over the metadata, give it a new outer. If that is relevant to your specific game for whatever reason, for maybe performance reasons, especially if you're doing something multiplayer related, I can imagine that being a thing. That's something you can do. I think just assigning everything to the player character is easy and usually more than stable enough. That brings us to the second half of this metadata thing, and that is merging the stacks. So for that, let's go back into our inventory utilities and make another function here. And this is going to be taking in one input for the metadata to compare, which will obviously be a BP metadata. And then it's going to be outputting a R equal value for a bool. And much like before, once we have made that a function here, let's give it a name actually, compare metadata, and we go back into our metadata. We now have this compare metadata function. And here we can do something actually quite similar to copying the metadata. First and foremost, we would need to cast this to another metadata class if we are doing this with a child metadata class. So if we have like sort metadata, we would cast to sort metadata and then get it out of there. But since this is just the base metadata class, we can just simply get counter from this and then get counter from this. So that's just this counter value over here. And we'll just check, is this equal? And we'll just simply return that. Now, if you have multiple values to check, you just want to check a AND boolean with a bunch of different pins and see if they're all equal. And if you have a cast to BP metadata, for instance, and you do that, you would also add in a return node here where R equal is false. Because if they're not the same class of metadata to begin with, they're definitely not going to have the same actual metadata inside. But for this simple class, we don't even need that. And this is the simplest way to check that. So implementing that in our item slot stuff here, which this function specifically probably needs to be collapsed into a couple of different other functions and stuff like that. I'll probably make one big cleanup video just so that everybody is aware of what I've changed in the eventual project files for the patrons and stuff like that. But somewhere in here we have merge stacks, and there we are just going to check, hey, both of these, before we do anything else, I'm going to take the source metadata or the target one, it doesn't really matter. And we're going to compare metadata, and we're going to compare that to the other one. Because if these two are not equal to begin with, there's no point in doing any of the other calculations, because we're not going to be merging these things together anyway. And we need to give like a feedback value as to this being unable to merge. So we'll put in a return value here. And we haven't had return values here up until this point, but we will need to do that now. So let's add in a was merged, capital M, just so that it makes it separate words. And it was not merged if we do any of this. But if we do this stuff, it was merged. Let's see, do we actually do anything with that in the item slots, like afterwards? So if nothing here was merged, what we want to do is we put in a branch for that, and we don't do anything. So we only do the rest of this code if a merge actually happened. And we'll make sure that we like return here with a was merged true. Now we need to make a way to differentiate between the different metadatas on different stacks, which is something that I wanted to show you anyway. So I had that counter value on the metadata object just because it's easy to like count how many times something has been clicked. So let's go into the item slots here. So when we click on one of these, let's see, on mouse preview button down, what we'll just do is we will get the inventory slots, we will split the structure bin, we'll get the metadata, and we'll get the counter, and we'll just simply increment this counter for just debug purposes. Obviously, this is not going to serve any actual gameplay reason, but it'll show us nicely. And now that we're at it anyway, let's also print string. This might crash when we press on a thing that doesn't have an item in it. It just gives you some errors. But as you can see, when I click on this one a couple of times in a row, you can see it starts counting up every time I click on it because it's got that metadata. But then these ones, of course, have their own independent metadata. And if I split these, it will copy over that metadata. So this will now keep counting 5, 6, 7. And this will now keep counting as well, 5, 6, 7. Now that it becomes 8, I can still merge them together because clicking on it technically increase the other one to 8 as well. So let's split these apart as well and click on these a couple of times. So now they're definitely not the same value, and it will not allow me to merge them anymore until I've clicked on it enough to the point where they are back at the same metadata value. So our splitting of stacks with the metadata and our merging of stacks only if they have the same metadata now works as well, which is quite an important piece to this whole thing. Then I think we want to dedicate a separate video, which is going to be a shorter video, to having child classes of the metadata object and implementing those. So maybe next time we'll make a metadata object for the sword so that we can have like enchantments for the sword. For now though, we're back into a functional system where we can start adding new features, and adding new features is always more fun than fixing up things that your previous new features have created. That's just what programming is, man. It's just get used to it. We have the basic setup for our metadata system. So now let's actually take advantage of everything we have set up and start making specific metadata classes for specific different items. Because right now everything just shares the same metadata class, which just has a little counter variable on it. But if we have a sword, for instance, a sword might want to have different sorts of metadata, like having a extra damage enchantment or having a durability on it. So let's take our metadata class and make a blueprint of that, and we'll call this BP metadata. You could even get rid of the BP if you really wanted to. Let's actually get rid of it and just like make this the naming convention in this project. Everything that's going to be a metadata class will just start with metadata underscore, and we'll call this weapons, or just weapon. Now, strictly speaking, you might want a different hierarchy where you have a metadata class for the tools as a whole, and that will have things like durability and maybe enchantments like unbreakable, if we're taking something like Minecraft, that are to do with that durability, and then make children of that tool class to support the metadata for your swords or your shields or your other kinds of weapons. How you're going to set up this metadata object hierarchy, much like the actual item object hierarchy, is entirely up to you and your game. Just do give it a little bit of thought beforehand, because changing this after the fact can be a little bothersome. But for now, we're just going to make a couple of variables. So this will be our enhanced damage level, which will be a integer. Every level is just going to be adding 10% extra damage, something like that. So this is going to be an integer. If you just want this to be a flat extra bit of damage on top of the weapon's damage itself, of course, you could make this a float instead. And then let's also give this thing a durability, which honestly can also be an integer, because by and large, the way durability will work is it'll be a whole number out of a whole number. Which actually brings me to another thing, which will be the max durability. If you have a project setup that already has things like health, maybe, or mana, there is a good chance that you have something like a struct that holds a current and a max value. You might be better off using something like that for the durability here as well, which is going to give it two different values. These are going to be the values that the sword can have. So now that we have this, let's go into our sword item blueprint, the class, the weapon. And in here we can say what metadata class this is going to use. And now that we have a new metadata class, we can say this is going to use the weapon metadata class. That's really all that we need to do in here, because now when that gets constructed, we can see all the metadata objects that we have. A bunch of them are just metadata, but two of them, because I picked up two swords, are metadata weapon. So it does create objects of the right corresponding class. So now, how do we use those? The answer is the most scary thing to people who don't know what they're talking about, and that is casting. You could set up interfaces for a bunch of this stuff as well, and specifically for things like durability, it's probably good to set up an interface instead if you don't have a very strict hierarchy where durability is added in like one step of the parent-child hierarchy. And instead you have a bunch of different classes with all kinds of like durability stuff. It might be good to make an interface to get that through that method instead. But let's just put in a progress bar and make that a child of this overlay as well. And we'll just kind of put this progress bar in roughly the same spot as this item slots, and then make it go a little bit lower as well, maybe a little bit lower still. That's pretty good. It's just a little bit tiny at the moment, so let's do something with that. For right now, we're going to kind of hardcode this to only work with weapons. You want to set up a interface for this, realistically speaking, or just structure your hierarchy for your objects a little bit better. But we're going to go into the item slots here, and in the item slot we're going to add one more thing, and that will be a progress bar. So we'll add a progress bar, which we will add in the overlay here, and we'll add that at the bottom, and we'll make that like just as wide as the slot itself. You can just keep it blue for now, that's fine. And we will check at the very end here. So if has item is false, we definitely want to be setting this thing to visibility hidden. But we also want to check at the very end here whether or not what item we have in our item slots, the metadata, whether or not that is of a type weapon. So let's get this inventory slots and also move it like all the way over here. And then we just want to cast this to weapon metadata. Again, if you set up a interface for this, it's a lot easier because then you can have a bunch of different things with metadata, and just as long as something returns some type of metadata with a durability in it, it'll work better. Because now if you also make tools that have durability and stuff like that, it doesn't really scale up that well. For now, this will do as an example. If that cast fails, we clearly don't have a weapon on our hands, so we want to set this visibility to hidden as well. But if this cast does not fail, we have a weapon. So we want to check, hey, do we have, we want to set that to, so we want to set it to visible instead. And then we want to set the percentage to being based on our get max durability and get durability. And then we just simply divide the durability by the max durability to get the percentage value of how much we have left. You will note that these create these normal light blue integer lines. So that's not what we want. We want to actually set these to take in floats, so that it will also output a float. Otherwise it's going to truncate and it's just never going to work. So durability divided by max durability, and then it's going to be outputting a float. And if you want to be really sure, you can add these to float, so that it actually uses floats to do the division as well. I never like doing actual math with integers, so that's why. I almost forgot to give these default values as well. We'll talk about setting specific default values up at some point in... So for now, let's just say the max durability is 10, and we'll start the durability, of course, then also with 10. Of course, you're going to want to set the default values for these on a per case basis for your item. So your item itself would, for instance, have 100 durability, and when it gets created initially, it will take that information for the durability and pass it along into its metadata object. We'll probably do that along with creating items that have metadata to begin with, like making a function that just takes in metadata so that you can make a chest that has an enchanted sword in it without you having to like go ahead and enchant it or whatever in a separate video. But for now, we'll just put in max durability and durability to 10. And now we will see that this thing has a little progress bar wherever it goes. So it has that durability. And even when it goes over here, it has a durability. It's a little bit squashed down because of the aspect ratio of the screen. But we have that. And we can even try to like pick up some rocks here. And in theory, if we craft a sword, it should also immediately show it with a, there we go, progress bar. So that works. Now let's see how it works when we use up some of that stuff. because the idea behind durability is that it will go down. So for, again, testing purposes, because durability can go down in a lot of ways in your actual gameplay, of course. So we're just going to add in a debug key on the character here. We already have a debug key for F. So we will just get the inventory component. We will query single slots. The item we'll find will be our sword, and we'll just try to find one of them. And then when we find that inventory slot, we want to break that. Want to get the metadata. Want to cast it to the weapon metadata. Because we already know that we're working with a sword, we already know that this is going to have weapon metadata on it, because swords get assigned weapon metadata. And then we can just kind of get the current durability, and we can set the current durability. This could be a function on here instead. It's just like subtract durability. Matter of fact, let's just do that. That seems like a little better to do it that way. So we'll just take a function, subtract durability, and we'll just take our durability and decrement it. It's really just as easy as that. And then we'll add a returning node with an output should destroy. Something like that. So if the output there now is less than or equal to 0, we should destroy it as well. So we can just subtract durability from that, and we'll get back the should destroy. I guess if should destroy is true, what we want to do is we want to get an inventory component. We want to clear inventory slot with the index corresponding to this inventory slot that we're working with. Now, I don't think this is going to be updating the progress bar yet, because in no way are we updating the UI here. So we'll probably see that if we do this 10 times, it's going to be destroying the sword that we pick up. So let's try that. So that's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It destroyed the wrong item. And then once it redraws the entire inventory, it did upgrade the progress bar. Why does it destroy the wrong item? It seems like when it initially gets added to the inventory, it has a index assigned to it of 0. That's probably something to do with this world item actor, because I haven't looked at that in a while. We try to add item, and if item is added, we... Okay. So add item itself. We'll add in the array index. This just adds one. Oh, it's always setting it to index 0 here. So it should be doing this over there. So I think when we created this metadata thing, I disconnected some stuff and didn't reconnect everything properly. So now it should all work properly again. So it should be index 1. There we go. So if I press this just 10 times, it deletes the item there. But every time we use up a durability, we won't actually see it update, right? Because obviously that's what we want. And honestly, the easiest way to just do that is to go all the way back here to before the branch node real quick, get our inventory component, and we can just call on inventory changed. Because our inventory did technically change, so it's just going to redraw the entire inventory for us every time we do that. And when it redraws the inventory, it's going to rerun that code and update the progress bar. Do we need to rerun the entire inventory for that? Technically, maybe not, but it's not that big a deal. So we can see that we are using up the durability here, and then eventually it disappears. So the durability now works. Now, we maybe want to do something a little bit better. So if we set up the inventory utils blueprint interface that we have here, we can just start adding some stuff. So we can start adding get durability, because this is going to be a thing that happens on a lot of classes. And being able to do this without casting is probably a good thing. So we'll take in the input of... So we don't need any inputs here. The only output that we're going to be doing will be the max durability, which will be an integer. And then we'll also do the current durability. And then we probably want to... And then let's make that subtract durability thing an interface, because there's a good chance that it's going to have to happen on multiple different things. And maybe sometimes on some things we want that to behave differently from other things as well. So this is an alternate way to do it. I don't think you necessarily need to do it this way, depending on how you architect your project, but let's just go over it real quick. So subtract, we're just going to call it subtract dura, because I'm too lazy, to be honest with you. And it'll have two outputs, the new current durability and the max durability. And if we then go back into our metadata here, we can see that we now have this subtract dura function, which is part of the overridable functions because the parent of this class, the WBP metadata, implements the interface for this. So this also has access to it. And here we'll just get our current durability. Again, just decrement it. The functionality is going to be the exact same, but we won't need to be casting anymore for this. And I suppose what we actually maybe might as well do is has dura as an output and make that a boolean. By default, that's just going to return false. That's an easy way to check, hey, did this interface actually do anything with the object that we requested it from? Because otherwise it's just going to be returning the default values. But if it does do something, we can refresh this node, and then it will return has dura as true. The new current durability will return, and then we'll also simply just return the max durability. And now we don't necessarily need to have this weapon metadata cast in there. What we can just do is we can just subtract dura as a message. And now anything that implements this will be able to interact with this fairly easily. And the has dura will just be... So we'll just put in a branch here for has dura. If it does, we don't need this one anymore. I guess we might as well also, while we are at it, add in the should destroy in here so that we don't need to do it at every place that we are getting the durability. So we can just check whether this is less than or equal to 0, and we should destroy. And then right click, we can just refresh this node. Now we have should destroy. That can just go straight into there. And now this will work the exact same way, but it is an interface. So for anybody who is losing their mind that I'm using casting, there you go. We have an interface and it works the exact same way. And now technically it is more scalable if your inheritance hierarchy is a mess. I think next time we want to talk about setting default values, some of this stuff, which to nobody's surprise, we are going to be doing with interfaces. We're just going to make interfaces for every single potential set of default values. And then we'll also take a look at making items generate in chests or just in your inventory that have custom metadata on them to begin with, because those two things will likely take up a lot of the same basic understanding of how the code works. I, at some point during this series, said metadata could be its own entire subseries, and I'm just kind of going through and making that subseries as just the second half of this inventory follow-up series. Metadata was supposed to be 1 or 2 videos. Welcome to like the 6th video about metadata. This is why I said it could be a subseries, because it kind of is at this point. Anyway, today we're going to be talking about setting up the default values for your metadata on a per item type basis. So we have 2 swords here, and maybe one of these swords needs to have 10 durability by default, and then the other sword needs to have 50 durability by default. How do we set that up? Well, it's actually not that complicated, but it's also not the most straightforward thing. So let's open up the relevant classes, which are going to be the inventory component first and foremost, because in the add item function is where we create the metadata to begin with. So when this metadata gets created, we also want to start like setting some values on it. And we're going to be getting those values from the items data assets. But how do we do that in a modular and scalable way in this function? Because we're not going to make like a if statement or like a branch or a sequence node or whatever for every single potential item in the game. That's insanity. Of course, we're not going to be doing that. What we're going to be doing instead is we're just going to tell this constructor for this metadata, after it's been constructed, we're going to tell it, set your default values and take in a item data asset. And then, you won't be surprised, an interface is going to take care of the on an individual basis implementation of what that means for every single piece of metadata. Because a weapon metadata is always going to be assigned to a weapon data asset. It's kind of a two-way street, the way we're programming this. So we'll be able to take the item input, pass it to a BP weapon, and then figure out the values of that specific object. We'll go over what it actually means right now. Let's open up our blueprints again and inventory utils, and let's add another function here. And the function we'll add is set default metadata, which is going to be taken in, as I said, the item data assets, which will be of type BP item. which can also take in all these other child classes of it, obviously, if it needs to. And then it doesn't really need to output anything, to be honest with you. So once we have done that, we can go into our metadata class, so our parent metadata class, because every single piece of metadata is going to need to have an ability to set this up. So we might as well just like check whether or not this exists in here. If it doesn't yet, you haven't implemented the interface. You go into class settings, you just add the interface. In our case, that's BPI. Well, the one we're working with, inventory utils, is already implemented. Otherwise, you implement it through there. So that's already implemented here. The default metadata thing doesn't need to set up any default values because it's just kind of a placeholder for if there's nothing else going on. But we also have this metadata weapon. And here we can say if we want to like override the set default metadata, we get this function over here, and that takes in the item data asset. Again, we know that this is going to be a weapon data asset because this metadata object only gets created in correspondence to a weapon being created. So let's open up that weapon actually, BP item weapon. And this has a bunch of default values that we can set here from just the normal item, but then it also has this damage float, and that's something that's specific to the weapon. Let's add something new. Let's just set the max durability, and we'll set that to being an integer, and we'll expose it. And then the default value for it, we'll just set it to like 10 or something like that. Actually, let's set it to 5 for demonstrational purposes, and make sure that it is exposed. Now that we have done that, if we go into the item assets, I've got this sword here, and you'll see that it has a max durability value now. So let's set it for sword 1, set it to 10. And then for sword 2, set it to 50. Both of these items will implement metadata weapon, and they both inherit from the BP item weapon. So these two things will work well together. There is something to be said about this system that has a little bit of room for error. If your metadata object expects the item asset to be of a certain class and it is not, your setting of the default metadata isn't going to work. But then again, why would you do that, right? Why would you make this metadata that takes in specifically a durability and a max durability, try to set those values from an item class that doesn't even have those values? If you really wanted to, you could also get rid of the casting here and implement even more interfaces. Every cast in the universe can be replaced by an interface, and it does make things more scalable. Again, I am more of the opinion that you should just take care of having your... I'm more of the mind that you should just take care to have a sensible inheritance hierarchy and just pay a little bit of attention to like making sure that these classes match. If you're really, really passionate about not doing casting, go ahead and set up a bunch of interfaces. I really don't care. Anyway, back in the item metadata, with that tangent aside, the item weapon now has a get max durability thing because it has a max durability function, or variable rather. So we can just kind of set the durability and the max durability both to those, and now both of those will be set on a per item type basis. So now when I pick up sword 1, it will have 10 durability. When I pick up sword 2, it will have 50 durability. And because of how we set things up in the last video, it should iterate over the entire inventory until it finds sword 1. I don't think it's actually going to be able to find sword 2, but you'll see that this now has 10 durability, and I don't think it can actually find the second one. So let me actually... Again, this is just for debug keying anyway, so none of this actually matters that much. So we're just going to copy all of this over, and we're going to be looking for sword 2 as well whenever we do this. So let's just set up a sequence real quick, put all that down there, and then we'll be looking for sword 2 as well. And you will notice that when we do that in a moment, we will see that sword 2 will have significantly more durability than sword 1. Even though they have the same metadata object, it actually has different metadata in it. So let's pick both of them up. And when I press the F key... That's weird. And now that we have that set up, we can go back into the inventory component real quick. And here finally set up that interface. So after we construct our metadata object, we can set default metadata as a message, not as a direct function call. Direct function call might also work, but it is an interface, so let's make sure that we do it as a message. Takes in the item data assets, which of course we get from the item to add. that we already have in a couple of different places. So let's put that in. And now we'll be able to see that if we pick up both of these swords, one of them is going to deplete its durability a bunch faster than the other. So you can see this one has a bunch more durability because its durability is set to 50. They share the exact same object type for their durability. They have the same parent class for the item. They're just two different instances of those with two different default values, which both get assigned to their individual item slots. Now we can just move this around, of course, and everything will still work fine because our code is good like that. Now that brings us to adding new items to an inventory that have metadata pre-made for them. And that is actually going to require us to go back into the inventory components, because if we want to do that, we want to make the metadata outside of this function. And we just want to supply in that metadata, because it's a little bit more tricky to do that. So let's just make a new function called add item with metadata. And we're going to add item here. And for now, what we're going to do is we're just going to copy over the add item into new slots. If there's already a slot that exists with the same metadata, we can use the compare metadata interface that we have set up for that to just add that into the new slot and stuff like that. That shouldn't be that difficult. And then we'll do this stuff up here, but we'll just kind of like copy all of this stuff over and make some minor changes. So first and foremost, we're going to, for this one, take in an input, and that input will be of type metadata or BP metadata. And then the very first thing that we do is, instead of just checking, hey, do we have an item, and is that item to add equal to the item that's already in there, we'll just, and does it not exceed the max stack size? We add just yet another bool, and we check, hey, is our, let's call that new param, the metadata or custom metadata, something like that. And we just get our custom metadata, and we compare that metadata, which is going to have to be a function call. So it's a little bit more messy to set all that stuff up. And then we'll compare it to the metadata in any given slot. So that will just go into that end boolean. And now it's also checking on every slot, hey, does something with this exact metadata already exist? Because then we can just add it to that stack. So if we have like two swords that can stack for some reason, and they both have the exact same metadata, meaning the exact same durability and the exact same like everything else, they can stack like this now, I suppose. For some items that have metadata, this might make some more sense to be able to stack, but it can do that now if you really want to. The interesting bit is we just check if the item slot was added, because that's what we do up here. If it is not, instead of constructing a new metadata object, we just get the custom metadata and pass that in. We don't need to create anything. We don't need to like set the outer to the player character or whatever, because we're already making this metadata object somewhere else outside. We just have to pass it in because it's just a pointer. It's just going to be that easy. So when this is false, we set that array element. And then we can set the default metadata. I'm going to say that we don't want to do that here either, because setting the default metadata is going to override any of the custom metadata that we're putting in. So whenever we put in custom metadata, what we probably want to do is we first want to set all its default values and then override them and then supply it into this function. So let's delete that as well and hook this back up. So this is starting to look a lot more like the pre-metadata version of this function, just with this compare data function call or the interface call in there. It's actually remarkably simple from this side of the equation. You might need to create some local variables though. So we need to create a local variable for has found item slots. The to add should actually be a input. I forgot to do that. So the item to add will be of type BP item. You might need to replace some of these references because they might break a little bit in some places, but that's not that big a deal. Let's see, there's one down here as well. It'll just tell you where there's an error and you can just fix that. So now we have that function working. Let's set up a chest that will create a sword with 100 durability. Is that crazy? Well, not that crazy, but it's going to show things up fairly well. Now, this is the kind of stuff, for the most part, you are going to need to hard code in, because you can't do this on the editor screen here. As you will see, if we open up the inventory component here, we can hardly just say, hey, I want to create this metadata, because this metadata field, you can't really put anything into it. And you also can't really make a field in which you can input a potentially like infinite amount of different stats or metadata to supply. So what you'll need to do is you'll either need to make specific components that do that on begin play, or you need to make specific other blueprints to do that. We're just going to make a component for adding that sword. And once you've made a component for adding a sword, you can then give that thing some exposed values to add those specific metadata and change those on an instance per instance basis. So that's why I like the component route to go with here. So we'll make an actor component, and this is add sword with metadata. And of course, you can make this as crazy as you want. You can make it add like 5 different swords with some amount of randomized metadata and that kind of stuff. We're just going to make something fairly simple. We're going to get the owner, which is going to be an actor. And from that, we're going to get the inventory. And we'll just get the one inventory. This one doesn't need to use the extra inventories. And on begin play, what we'll do is we will just item with metadata. The item will be a sword, a normal sword, which usually would have just 10 durability, as you might recall. And then we will construct a object from class. We'll construct the weapon metadata. This time we're constructing a specific weapon metadata because, again, we know that we're going to be applying it to a sword, so we might as well. The outer for this, I'm going to still just get the player character. Again, you can make the outer for this the inventory that it spawns into, and then anytime you move inventories, you need to like recreate the metadata to supply the right inventory and that kind of stuff. That is technically better, and especially if you're doing multiplayer stuff, that might be necessary. We're just going to assign everything to the player character. And then in here, we now have our constructed meta weapon. Now we have our constructed metadata for the weapon, and we will set the max durability to 100. And this is the fun part, right? So we can actually set the normal durability to something else here. So we can make a sword that is half used up, but has potential if you have something that can restore durability. It has a max durability of 100, but it will have a normal like durability of, let's say, 25. So it's not that much more than a normal sword. It's less than a sword too, but it has the potential for a lot more durability. So this is the kind of fun stuff that we can work with. And of course, those are going to just be the default values because we're going to be promoting this to variables, both of these, so that we can change these on a per chest basis. And then all we need to do is we need to supply in that custom metadata object here, and that will be all. It'll only add it in if there's room in the inventory, of course, but by and large, we should assume that there is room in the inventory for that. And now we can get this chest and we can copy it over. I'm going to say that this inventory is going to be empty on startup, and this one will still have the rocks in it. And you can actually add components on a per instance basis fairly easily. So we can just say here we want to add a sword with metadata. This one is going to have 100 durability and 20 for its max and 25 in total. And then this one, oh, I just copied over the static mesh. Let's copy over the entire actor. It'll already have the add sword with metadata. This one is going to have 50 max durability, but it'll start with 40. So we will be able to see now, if I just save this real quick, this will have a, well, that's not great. I think we never set up a get inventory for the chests. Huh. Okay, let's do that then. Right, so we uninteracted. I guess we never needed to. Yeah, we already like implemented the interface. We just never gave it a like implementation for that. So we'll just get inventory here. Didn't do that apparently. Let's try again. It clearly didn't work. So this one will now have, oh, it still doesn't do anything. Why doesn't it do anything? Why doesn't it have anything? Because I added that. Runs before this begin play, and then it immediately clears the inventory. No, it shouldn't. But it does. And one last thing that you might run into. Let's get rid of it. And one last thing that you might run into is that it doesn't show up in the inventory at all. And that would be because the add sword with metadata components begin play would be running before the chests begin play. And the chests begin play has the inventory constructor on it, which might interfere with that a little bit. Honestly, the easiest way around that is just to delay this by a little bit. whenever a chest spawns in, you're not going to be immediately opening it anyway. There's going to be seconds to minutes to a very long time potentially before you even open the chest to begin with. So this is actually just a fine workaround that still allows you to modularly say, hey, I want to add a component to this chest to add this type of item with this metadata. And to show you that, again, this one will be adding a sword with 50 max durability and 40 current durability. And this will be adding a sword with 100 max durability and 25 current durability. And just like that, if we open up this, we can see, hey, we have a sword here that is mostly filled up, but not entirely. And then we have a sword up here, which is mostly used up. But as we open up the inventory here, we will see that this one takes that much damage every time I press the F key. And it's just taking the first one in the inventory. And this one takes that much damage, which is a fair bit less. Like, actually, it is about half. So that is how you can set up these components to add in specific metadata related objects. And you can do whatever you want with this. You can make this as wide and as deep as you'd like it to be, but this is the basic concept of it. And from here, knock yourself out, be creative. But I think at this point we have talked enough about metadata. I think we should call it an end for the metadata portion of this, and we should actually maybe soon call it an end for the entire series. But before we can do that, we need to do something very important, and that is be able to save our data. Because an inventory is kind of shit if it resets every time you reload the game. So next time, we'll talk about that and wrap things up properly. We have finally made it to what might be the end of this inventory course. So today we're going to take a look at saving out our inventory and being able to load it back in. Because, of course, if you have an inventory, you'll want to be able to save and load what's in it. Otherwise, there's not really a point to introducing it into your game, is there? And while we're at it, we're also going to just touch up a little bit about the equipment slots so that they can actually be saved and loaded as well. At the moment, they work, but they're a little iffy in some ways. So let's take a look at how we can get started with saving and loading. We have our inventory component, which has a bunch of functions on it, but all those functions really only serve one thing, and that is setting up our inventory array. Everything else is to serve the inventory array. So this is a thing that we're going to need to save. And the inventory array is an array of a struct that we have made. And that would be this inventory slot. So we're going to need for every inventory that we have, every inventory slot, we're going to need to save the has item and the stack size, both of which are going to be easy. It's just a bool and an integer. But then we get to the item asset, which is a reference to a, well, item asset. And we can't just save references like that to a save objects, because this isn't a real value. This is a place in your system's memory. And if you save this, then close the game and start it back up, the asset is going to be in a different place in memory. Potentially even throughout your playtime, if you unload this asset for any reason and then the engine loads it back in, it might be in a different place in memory. So you can't just say, hey, save this and we'll go from there. So we need to somehow save out the item asset as something that is not a direct reference. We'll take a look into how to do that in a moment. The index, of course, is just an integer. We can save it out. And the metadata, we have a similar problem to as the item asset. Because it is an object reference, it is just a pointer to a place in memory. So we can't really save that. On top of all that, metadata, the whole point of this is that it could contain a whole bunch of different types of data, depending on the type of metadata objects that we're assigning to this. That's why we made the entire metadata system. So how in the world are we going to save out something that we don't know in our code what is actually going to contain? We can't very well make different save objects for every single type of metadata objects that we could potentially be saving, because that would just be a pain. That wouldn't work very well. So we need to serialize this into a format that we can easily read and write from and to. That is the basic overview. Let's actually just get started doing it now that we know what we have to do. So We're going to make something in either the game mode or the game instance. Wherever you prefer to put this, you can put this. You could even make it into like its own like game module. So it's a little bit more plug and play if you want to put it into like different projects and stuff like that. For now, we're just going to go and make a blueprint class for the game mode base. That's just the easiest place to put this. So let's call this game mode inventory, something along those lines. Now it is important if you do this in the game mode or in the game instance to go into your project settings and look for your game mode. The default game mode we should set to the one that we just made. If you did it in the game instance, of course, you need to set the game instance class to whatever game instance you just made. Either or works. So let's open up that game mode. Before we forget, I'm going to set the default pawn back to the third person character. Otherwise, it's not going to be spawning in the default pawn there. Everything else we can keep the same for now. And here we can start making some new functions as well. So let's make a save inventories function. And while we're at it, we might as well make a load inventories. And I'll just get started with these save inventories. So we're first going to check whether a save game already exists with a given name. You can just put in the name directly here. We're just going to make that a parameter because it's easier to set up and have multiple save files that way. So that'll be the save game name. And then we put in a branching node. And if that already exists, we're going to load that save game. If it doesn't exist, we're going to create that save game. So does save game exist? Yes, we're going to load game from slot, and the slot will just be the save game name, which we can just get save game name because it's a local variable as an input parameter. And if that is not the case, we will create save game object. And the save game object that we're going to be creating will be of type. We still need to make that class. So let's go ahead and make that class now. We can just make a new blueprint class. We'll look for our save game as the parent class. And we'll call this SG for save game inventory. Something along those lines. And here we're starting to get to having to make some new stuff. So we only really need to put one variable on this for now. Of course, if you have a game with a lot more stuff that you want to save than just the inventories, everything you want to save is going to exist in this save game class. But for now, this will just be the inventories that we save. That's all going to exist in this one variable. And the variable is going to be of type string. And we're going to make that a map. So the string will be the key. So we can give in a string and it will give us the corresponding saved inventory. Of course, we do need to make a struct that contains our saved inventory. And for that, we're going to need to make a struct that has an array in it of inventory slots, but not just normal inventory slots. Because of what we just talked about, we can't save everything in a normal inventory slot. So we need to make a specific struct that will store everything in a savable format. And then we're going to be saving an array of that in our save inventory struct itself. If that confuses you, don't worry, we're going to go over it one step at a time. So let's get started by making a new blueprint structure. And this will be the str for struct inventory slots save data. And if we open that up, we can, as we discussed, just put in the has item. The stack size, we can also just put in, that will of course be an integer. And then we can add in the item assets path instead of just having the item asset reference itself. So what we're going to be doing is we're going to be saving the path of the item asset, so where it exists in our project, as a string. So that way, when we get an asset, we can get its asset path, save that. And then when we need to load it back in, we can use the asset registry to get the asset from its path and load it back into the right place and do it as we need to do. So then we have the index, which of course is just going to be a simple string. And then we get to the metadata. And for that, we're going to need to do a couple of funny little things, but we're going to be storing those as strings as well. We need to set up something to serialize this. Again, into a way where we can put pretty much like arbitrary data into a string, and we're going to be putting it into a string array so that we can also read those back. And strings are just very, very useful to put arbitrary data in because you can literally put anything into a string. and then you can read those back and do with that as you want to do in your code. So this will be our inventory slot save data. And then we make a new struct as well. So we're going to go into blueprint structure again. And this will be a str inventory save data. This is going to be for the entire inventory. And all that this will be is our slots. So this is going to be the inventory slot save data, and it's just going to be an array. And the reason that we do that in a struct is that this is the only way in Unreal Engine to make a map that has an array in it. Unless you're doing C++, in which case you can just make a map with an array in it, but Blueprint doesn't allow you to do that. So this is a little bit of a workaround for that. I do feel the need to point out that you should try to avoid doing this, however, in actual gameplay. We're doing it here for a save system, so it's kind of fine. But doing a array inside of an array, like these nested arrays, if you can prevent doing it and do something a different way, it is better, because this is a nightmare for your CPU to look up all over the place, because this is gonna not be efficiently stored in memory. But since we're only saving and loading this stuff as save games, it's not that big a deal here. Anyway, back in our save game, we have our string map, and we're going to put in our inventory save data. So not the slot save data, but the inventory as a whole as the save data. So now we can just give it a default value just to show you don't need to give it a default value. And after you do this, you do need to make sure to remove it again, but we can give it a name. And then inside of this, we have all the different slots, which have all this different data in it. And we're going to be populating that, of course, programmatically. So back in our game mode, we finally have our save game class. That took a little bit of time to set up, I know. But we can now say, hey, our save game inventory class is what we're going to be constructing if the save game does not already exist. And we will promote that to a local variable and call that something like save game. And then we also want to be able to set that save game after loading it. You'll note though that we can't immediately hook this up because this just returns a generic save object. So we want to cast that to our save game inventory. And then we'll be able to set it as our local variable. Now that we have our save game, the very first thing that we're going to do is we're going to get our inventories map, and we're going to be clearing that. Because sometimes it does a bit of a weird thing where if you try to override a slot with an item in it with a empty slot, so you want to clear out the slot itself, it kind of it gets a little bit confused. So the easiest way to fix that is just to clear the entire inventory array, because we're going to be making a new one here anyway. Now, the question is, how do we get all of the inventories in our game to save? Because it is pretty easy to just hard code, get your player character, get the inventories out of that, and just save that. But we, of course, also want to save the inventories from all of these things. So how do we do something that scales up easily and doesn't require us to go back in here and say, oh, actually, I also want to save this object, and across like a billion different levels, all these objects. That's just going to be a pain to deal with. So the way we can easily do that is with get all actors with a tag, and then we'll simply give a tag to everything that has an inventory. So we will, I just have this as a string copied over here. I will just give it the tag inventory to look for. And the neat thing is, if we go into the inventory components, into the event graph, which is still empty because everything exists in their own functions, we can get the owner of this component, which gets us an actor, and then we can get the tags on this actor, and we can add a tag to it, and that's going to be the inventory tag. And now automatically anything that has an inventory on begin play will be given the inventory tag. So we can test that by just playing, and let's go F8. Our player, of course, has like 3 inventories, as a matter of fact. So we look at its tags, and we can see it has inventory 3 different times. That doesn't actually matter that much, doesn't do that much. I guess what we could potentially do if you really wanted to, you could check if it already has this. So you can use the find node here and try to find inventory, and if it is greater than 0, that means it's found one and it doesn't need to add it again. If it doesn't find the inventory tag in the tags array, this will be -1 as an output. So if we just connect this up to a branching node, so only if this is not greater than 0, will we add the inventory tag. I guess the other way to do this is just to check whether or not this is less than 0 and then use true. That might make a little bit more sense. Depending on like how your brain works, you can do like one or the other. It doesn't really matter. Like less than and not greater than are effectively the same thing in this case. So now we'll see if we go in here, we should only have the one inventory tag because it only adds this once. Again, there's not really an issue with it having 3 of the same tag in this case, but maybe in some other piece of your code that would matter. So it's better to just set it up to only apply it once. And all these things that also have inventory components also have the inventory tag now. So if we go back into our game mode, when we get all actors with this tag, it will get us an array here with all those actors that have that tag. So on that, we can do a for each loop because we're going to need to loop over every single one of those. And first and foremost, we're going to get the inventory. And that's the interface that we set up a while ago that provides its own inventory components through this interface. And if it has more inventory components, it provides all of those as well. So as an example, if we go into the third person blueprint here, it has the interface for get inventory and it gives its own inventory component on the top here, but it gives its inventory component and the hotbar components for the array here. And we haven't actually added the equipment component to that yet since we've added it. So we also should be returning that. So first order of business being checking whether or not the actor that we're trying to save the inventory of has more than one inventory. So if we have the length of this array be greater than 1, so greater than 1, we know that it has multiple inventories that it is returning, which means that we need to do something slightly different and slightly a little bit more complicated in a moment here. But for now, let's focus on just saving out the one inventory. And we're going to be doing that with its own function, actually, because we're going to need to hook up that function to both of these things. And we'll call this one save inventory, singular, instead plural. And here I'm actually, to prevent any confusion, we're going to go up to the access specifiers and we're going to set this to protected. So this way, if we make a child class of our game mode, we can still run save inventory if we really need to. If you don't want that to be true, you can set it to private as well, which in this case might be preferable anyway, to be honest with you. So yeah, let's actually set it to private. But if you set it to protected, it will still be accessible through all of its child classes, but other classes will not be able to access it. So unlike the save inventories function here, if I go into my third person character and I try to access this from like that game mode and I cast to the proper game mode class, I'll be able to get the save inventories and load inventories. But even though save inventory exists on here, because it is protected or private, it won't be able to be accessed from other classes. This is just to prevent confusion, since we have save inventories plural and save inventory singular as two functions under each other when we look this up. I don't want people getting confused and accidentally only calling the normal save inventory function, because this function never needs to actually be called outside of the context of from where we're going to be using it here. Anyway, that's a very long-winded explanation of access specifiers. We need to put in a couple of inputs here though. The first thing that we're going to need to input is the inventory component that we're going to be saving. So let's do inventory components, which of course is going to be of type inventory components. Then we need to specify the owner's name, because that's how we're going to be saving and finding these things. Since we have a bunch of different inventories that we're going to be saving, we have that map on our save game object here, which has a key for a string. And that's going to be the owner's name. So that way, when we load these things, the names are going to be consistent between play sessions, because those are just baked in when you place them into the editor to begin with. So we're going to set the owner's name as the key, and then we can look up the saved inventory component in our save data by providing in the actor's name again. And then we also want to provide in a reference to the save game. So that will be of type save game inventory, of course, and that'll be all the inputs that we need. So from our inventory component, we're going to get the inventory array that we have, and I won't surprise you to see that we're going to be doing a for each loop over that, because we need to loop over every single inventory slot in there. And we'll pull off of the array element and break it, because we're going to need some parts of these outputs to construct our save data. And the way we'll do that is we'll make a new array here, and this will be the saved inventory slots, and that will be of type inventory slot save data. So this time it is the individual slots that we're saving to an array, not the entire inventory save data. So just the inventory slot save data, which is going to be an array. So now that we have that array, we can start adding to it. So let's drag that in. Again, it's a local variable. So every time this function will be called, it will create a new fresh empty version of it. And we will add to it. And we'll just split the structure pin and start hooking these things up. So first and foremost, we get this item asset and we check if it is valid. Because if it is not valid, it is an empty slot to begin with. And we don't really need to worry too much about any of this. So if it is not valid, has item will be false. Stack size will be false. The item asset path will be nothing. The index we do actually want to set properly, just because, well, it is the index value. And then the metadata can be empty as well, because if there's no item, obviously there's not going to be any metadata. The actual difficulty comes in when we start adding it in when there is an item, of course. So when is valid, we have a different adding node. And here we can pull through most of this. So we can do a has item to has item, stack size to stack size, index to index. But now we need to get the item asset to the item asset path and the metadata to a metadata string array. So let's do the easier one of the two first, because we can literally just pull up the item asset here and we can get the object path as a string. So get object path string, and we just plug that into the item asset path. That's honestly as easy as it's going to get. That now saves the path to where this asset is located. Do be aware, if you are actively developing your game and you change where that asset lives in your project, like folder structure, this will no longer be able to properly load, because it is physically looking through your folder structure to find the asset in a specific path. So if we go into my items and item assets, if I make a new folder and I put like my armor into that folder, if I then try to load in an inventory that has like armor pieces, it's going to try to just get them from this folder, because that's where they lived when I saved this. But of course, if I've changed that, it's not going to be able to load them in at all. So do be aware of that. Now, the metadata. This is the fun bit. It's always the metadata that kind of throws a wrench into things, isn't it? Let's go into our base metadata object. So that should be somewhere in here, BP metadata. And here we'll add two new functions as well. So we will add a get data as strings, and we'll also make a set data from strings. So as you can probably tell, what we're going to be doing is this one will get the data as an array of strings. So we will make an output, and that output will be just called data, and that will be of type string array. And we'll create a local variable here, and we'll call this data array, which will be of type string, and of course it'll be an array. And all that we need to do here is we need to just get this array, and we need to add something to it. And what we're going to be adding will be, in this case, just our counter variable. This is just the thing that exists on our base metadata class that we don't really do anything with. It was just for an example, but it serves as a good example here as well. So it'll take this integer and turn it into a string. So it'll just say the numerical value of what this is as a character and add it to this. Then once we have done that, we can get our data array and return that data array value. So if we just have a base metadata object with nothing else on it, this array is going to have one index with the value of this counter. But if we go into the metadata for the weapon, we have also the enhanced damage level and the durability and the max durability. So what we end up doing is we go into the functions here and we override the get data as strings. First thing we do is we right click and we add a call to the parent function here. And we might need to make sure that we compile the parent class first as well, if you don't have that yet. And this will just run this code before we add on some extra code of our own. So that also gets us easy access to this local variable that we have here. So we can just add a couple of adding nodes to this, 3 in total, as a matter of fact, because we've got 3 extra little bits of data to add in. So let's connect all of those up and let's make them look a little bit neat, because God knows I'm eventually going to have to do this for the Patreon download. And then we can just drag these in. So enhanced damage level, and then the durability, and then the max durability. And so it will first run the parent version of the function. So at index 0, it's always going to be putting in this counter. And then we will always know that consistently at index 1, we'll have the enhanced damage level. At index 2, we'll have the current durability. And at index 3, we have the maximum durability. And then if we even have a child class of this metadata for the weapon, like specifically for like a sword, we know that the next thing that we can add in will be at index 4. And 5 and 6 and 7, and if we then have yet another class that is a child of that, we can keep counting up and counting up. There is a little bit of iffiness here that you as the programmer need to be aware of how many things precede any given metadata object with how much data is getting added to these strings. Just adding it doesn't matter, but when we start reading it back with the get data from strings in a moment, you need to know at what index every single piece of data lives. Because after they've been saved, they're just strings. We can't like really filter on anything anymore. Anyway, here as well, of course, we add a return node and we return that string array. So that is the getting data from strings, and that's all that we need for now for saving things. But now that we're in the metadata object anyway, we might as well also do the setting from the strings. So this will instead take in a data array of strings, and we'll do more or less the opposite. So we'll set the counter value to getting a copy, and here we need to know the exact index of where the counter value is going to be stored. So we know that's always going to be 0 in this case, because it's always the first thing to run. And you can locally just say, hey, get this string and try to put it into an integer. If you put in a string that is not a number, this might have some wacky results, so just don't do that. And then in the metadata weapon, we can also override set data from strings. And here it will also first call the parent version of the function, if you have one. And then we can just set these 3 in order. So we'll just get a couple of getting nodes for this and all hook them up to this. And here we know, okay, so we set these in this exact order. So this one first, then this one, then this one. We already had index 0 used up by the counter in the parent here. So we know that we're going to need to get this from 1, 2, and 3. And we just connect these up. This is a little bit tedious to set up anytime you make new metadata, but for the most part, like once you have your metadata objects set up, there shouldn't be much reason to change this around much, so you don't really need to like worry about like working with all this too much. And that is how you set a read from that metadata array. Now we can finally go back into our game mode again, into our set inventory, the singular one. And now that we can get the metadata from our metadata object, we can get data as strings. We just hook that up here in the isValid node and then to the add, and we just provide it with that metadata. And then when all of that is completed, so when the for each loop is done and has gone over the entire inventory array, you might be thinking we haven't used the owner name or the save game yet, and you would be correct. So we're going to get this save game and we'll get the inventories map that we have, and we will add a entry to that. The string is going to be the owner's name, and the input here is going to be our saved inventory slots, because if we see this as our saved data inventory structure, that only had an array of these things in it. You can't quite like just put this in directly. It's not quite how that works, but we can just make one. And all that it takes to make this kind of struct is just an array of these ones. So that's how we can put that in. And then we just hook that up to on for each loop complete. And that will add this inventory that we're saving to our save game object. So let's go back into the save inventories, like the grant parent function that we have here. It's not quite a parent, but like the function that we'll be calling the save inventory function. And first, the easiest, because we were checking here, get inventory, whether or not we have more than one inventory that we're returning from this interface. If not, we're only ever saving one inventory on this thing. That is the easiest situation that we can find ourselves in. So we can just save inventory, the singular one, and we can just get that inventory component. We'll always know that, hey, if we're not returning more than one inventory here, we'll just use this bin if you have all of your implementations set up for this interface properly anyway. Then we will get the actor out of our for each loop. If you remember, we have all actors with tag that we're getting here. We're doing a for each loop over all those. It's been a while since we've actually set that up, so I'm just reminding you. And we can just get the display name from that, and that will be the owner name that we put in here. And then we have our local variable for the save game that we can put in just like that. And this is how saving singular inventories works. So if you just have things with only one inventory per actor, this is all that it takes to save these things. But of course, our character has 3 inventories, one for the inventory, one for the hotbar, and one for the equipment. So if any character in your entire game has more than one inventory, we're going to need to set up just a couple more nodes here. So if we do have more than one inventory, we do a for each loop. And what we'll do is we'll go over the entire array of inventories that we're getting provided with. And each one of those are going to run its own save inventory function. This is an array of just inventory, so we can just immediately put the array element into the inventory. The save game will still just be our save game local variable that we have here, but the owner name is going to be the thing that is a little bit more tricky, because we're going to get the display name from the actor that the array exists on. So we have an actor that has inventories, and then we're doing this loop over the inventory. So we're getting the display name from that actor from the first for each loop. And we're going to be appending something to that. So we'll have the display name of the owning actor, and then we'll just add the array index to it. This way, every single one of these inventories still will be able to be recognized with what actor they exist on. And since this always gives you an array in the same order of indexes anyway, we can now differentiate between different inventories on the same actor. So the owner name for the character will just be like player character 0, player character 1, player character 2. And that'll be the 3 different inventory components on our player character. And once that all is done, we go back to the for each loop, the first one here, for the get actors with tag, and we finally save game to slots. And we'll be saving the save game object that we've been working with, and we will save those to the save game name. As you remember, that is the input parameter that we have over here. And that's only the saving half of things. Don't worry though, while building up this saving half of things, we set up a lot of stuff like all these different classes and these new structures that we're using. The loading half of things is actually going to be significantly easier now that all the pre-existing functionality has been set up. So let's go into load inventories. And here we also check, does save game exist? We're going to be checking the save game name, save game name. This is actually a lot easier, because if this does not exist, we just don't do anything, because if the save game doesn't exist, there isn't anything to load. It's just as easy as that. So false, we just don't do anything. If it is true though, we load game from slot. And we're going to be loading the save game name. This will give you a return value of a generic save game object. So of course we need to cast that to our save game inventory, and then we can promote it to a local variable. We'll call that save game just like before. And once again, we can just get all actors with a tag. And I'm going to, just to be sure that we are using the exact same thing, I'm just going to go over here and save inventories and just copy over and paste. Don't want to have any typos just sneaking in there. That would be bad. And we can, once again, go over a for each loop with all the actors that we find. And here we do something very, very similar. When we find an actor, we get its inventories with this message, just like we did before. We check the length of this array. We check whether or not that is greater than 1. we put that into a branching node, because if it is greater than 1, we need to load in multiple inventories. We'll set that up in a moment. But if it is not greater than 1, it's just loading in one inventory, which is quite simple. So I guess you know what is coming now. Just like we made a singular save inventory, we're going to make a singular load inventory as well. And this one also will require similar inputs. So first and foremost, we will put in the inventory components, which will of course be of type inventory components. Then we'll put in the owner's name, which of course will be a string. For this one though, we don't just want to do the owner's name. I'm also going to put in a name suffix. And this will be the 0, 1, 2, 3, 4, whatever we want that we put in with the saving. We're going to be combining those things back together inside of this function. So if we only have one inventory, a character, this name suffix is just going to be empty. But if we have multiple inventories that we're loading in, we're going to be putting in the index of another for each loop just for this name suffix. So then this will combine back into owner name plus suffix, which will be the exact same thing that we put in when we were doing the actual saving. And then of course we also need the reference to our save game object, which will be of course our SG inventory, and that's all the inputs that we need for now. So having our save game object here, we can get our inventories, and then we try to find an inventory based on the combination of these two things as the name. And that's going to be returning us with the inventory corresponding to that actor, and specifically even to like the exact inventory on the character that we're looking for. So we can break the output from this to get the individual slots as an array. And of course, we're going to be for each looping over that, because that's just what we do. We do that a lot in this video. And the very first thing when we load in an inventory slot to do anything with, we want to clear that slot just in case anything exists on it. So we just get the array index, put that into the clear slot index, and we clear the slot because we're going to be repopulating it with the saved item in a moment anyway. And then let's get our inventory component, which you actually can just like get inventory component, because again, you can get these input parameters as local variables. We'll get the inventory array, and we will set an array element. And we're going to be setting these things manually bit by bit. So we'll split the structure bin open. So of course, the index of the array as well as the item index here are both going to just be taken from the array index in our for each loop. And then we get the array element itself from the for each loop, which again is going to be the saved data from the inventory slots that we saved. So we can break this open and we can see that this has the has item, the stack size, the item asset path, and the metadata, because that's how we save things. So obviously we can just pull through the has item, we can pull through the stack size, and we could pull through the index through here as well if we wanted to, like same difference, honestly. Now though, getting the metadata back in there and getting the item asset path to load the proper item in there, that's the slightly more tricky part. So let's do them from top to bottom. So first, item asset path. What we'll do is we will get the asset registry, and this is just a general function to get a reference to Unreal's asset registry. It's very descriptive in what it does. And when we have the asset registry, we can get assets by object path. We're going to be using the singular version. You can also get multiple assets by object path through this. So if you just put in a folder, it'll give you all the assets in that folder. We just want to get a singular asset in this case, so we're going to be using the top one. And the object path will be our item asset path. And in our case, we don't need to include disk-only assets because these data assets will live in memory, not specifically on the disk. So when we get that, we get this structure that has the asset by object path, which is not that useful. But from that, we can just simply get the asset, and it will give us the asset as a generic object reference. As you can see, we can't put it in there yet. So we just need to cast that to our BP item. And if that cast succeeds, then we can put that back in there. So that loads in the item asset again. And now all we need to do is load in the metadata. So in order to load in the metadata, we do that after we have the item itself. And we construct an object from class. like we did before. And then from the item, we get the metadata class. And we're going to be constructing an object of the corresponding type. The outer, we just get player character again. Once again, you can very much upgrade this to have its outer be the specific inventory component that it belongs to. But that makes switching between inventories a little bit more tricky. After we construct the BP metadata, we can set data from strings, because that is the function that we made a while ago. And the strings that we take in will just be like this metadata strings that we're getting from this break, from the for each loop. We can just provide that in. And then we also, coming over to construct BP metadata, just provide that in as the array element here. And with all the noodly goodness, that is all there is to it to make you load the inventory. Once all that is done, we simply get our inventory components. So we can just get inventory components, and we will call inventory changed, because we've just added a bunch of stuff to the inventory, and we want to be able to like visually reflect that. And that's how our inventory widget works. It works on this event dispatcher. Now we have the load inventory function ready, and now we can implement that in our load inventories function, the plural one, in much the same way that we did for saving. So if the length is not greater than 1, it's just simply one inventory that we're loading onto this one actor. All that we need to do is we need to pull over here, load inventory, and we just put in the singular inventory components. We get the actor from the for each loop. We get the display name, simply put that into the owner name. Since we're only loading one of these things, we don't need to provide in a name suffix. And the save game that we'll be working with will of course be just save game. If, however, we have more than one inventory that we're working with, what we're going to be doing is, of course, we get the extra int array and we do a for each loop over that. And we take the array elements, goes into the inventory component. We get the display name here, and we have given the name suffix as this. You could, I guess, also do that outside of here in the same way that we did with the saving. That would work just as well. I just wanted to show you like both versions, I guess. But for the sake of consistency, you might want to update one or the other so that they both use the same method of either taking in like the name and the suffix, or doing it like outside of the function, like in here with an append node. That's entirely up to you, what you prefer. Of course, we put in the save game just like that, and then we loop through. It's really quite straightforward once we have the function itself set up. And now we have saving and loading of all our inventories in the entire game working. If we go into the third person character here real quick, and I add in, we have this debug F key. Let's also add in a debug G key or something like that. We can get the game mode, cast that of course to our game mode inventory real quick. We'll do that for both of these, and on pressed for one of them we will save inventories, and you can see we only have the save inventories. We don't have the singular one, only the plural one, because we set that to either private or protected. What you will note, however, is if we try to load the inventories, I didn't mark the other one as private, so we can access load inventory by itself. You don't want that confusion, so we're going to go back in and set that to private in a moment. So we'll load inventories, and we'll just call this like save, that we're going to be saving and loading this to. Of course, if you have a whole save system and stuff like that, you can make this a variable and do like fancy stuff with that. I have separate videos on save systems. And do make sure to check whether or not your game mode override is set to anything, because right now it's still overriding this as third person game mode. So that cast is failing. I had a little bit of a weirdness about that, so I needed to test that. But just make sure that you don't do that. And if we pick up some items now from here, let's also pick some items out of these chests that I put them in, something like that and something like that. We have a bunch of items in our inventory and a bunch of line traces all over the place. Open my inventory up. Let's move some items around a little bit. Save our inventory with the F key and move them around a little bit more. Load our inventory back in, and you can see they snap back to where I saved them. And now let's take out these items as well. And now I will load the inventory again. And you can see the items will disappear from here, and they will be back where they belong in the chest. So everything works more or less perfectly, again, except for the whole equipment thing, because that doesn't properly update its inventory component yet. This video is very long as it is, so we're going to go through that very quickly, just to wrap things up real quick, because you do want to set that up properly. And if you're getting errors like these, by the way, access non trying to read inventory component in a couple of different places, you might want to, in both the save inventory and load inventory, just put in a quick is valid. And note, this shouldn't change anything about the functionality because it's being an issue anyway. It's not going to crash your game, but it will prevent you from getting these error messages. Equipment slots, while they work perfectly fine for putting things in and visually displaying it and having the data in them, they don't seem to yet be updating the corresponding inventory components, so it doesn't actually get saved through to there. That is a pretty quick fix though. So let's dive right into there. We'll go into the inventory folder here. And I have this player inventory where these are just like loose empty inventory slots, and we need to like set up some stuff for that. So we at some point started building in this on item changed for specifically the weapon slot and then didn't do anything with it. So now we're going to do something with it. That something will be not quite here yet. We're going to be using this exact same make array that we have that we're setting the inventory components on each of these slots with. And we're going to be looping over them a couple of more times. And since we're looping through the same array anyway, we might as well get rid of the sequence node here and just do everything there in this for each loop, just so that it's a little bit less messy with a bunch of separate loops doing separate things. So the first thing that we're going to be updating here is in the inventory slots. At no point while creating this do we set the index in it. So first things first is we want to set member, and then we can come over here and set the index. So this will just set the index to the for each loops array index. That fixes issue number 1. Then we also want to, for every single one of these, assign on item changed. And at no point are we actually calling this. We'll set that up in a moment. We'll call this item changed. And when the item changes, we need to do some stuff. So let's go back into the inventory slot and set up a couple of little changes there as well. Because we have this on mouse preview down thing, we have redraw item slots in like a bunch of different places here. We can actually get rid of all of these because we're going to be doing that through the event dispatcher next. And instead, we will call item changed. Because whatever happens, like whatever path we go down here, the item will have changed. There will be a separate like new item or like a new value of an item or whatever in that slot. So whatever happens, we always end up with on item changed. And the on item changed event dispatcher that we have up here is actually going to take in a new parameter. And the parameter that it will take in will be the updated slot, and that will be of type WBP item slot. So now it has that as a parameter, and we'll just get that a reference to itself because this thing itself is what was just updated. Down here, when we clear the inventory slot, we set the inventory slot to being entirely empty. Obviously, we don't want that, because we still want the index to be properly assigned. The has item and stack size and all this can be default values, but we should remain with a properly set index. So we can just get the index from this break node over here and put that into the inventory slot there. So now that we have that fixed up, that's going to prevent some other issues in a moment. We can go back into the player's inventory. So that's this widget over here. And this item change will now have the corresponding like input parameter that we can actually start doing stuff with. So when we do this function, we're going to take this array and we're going to be finding the slots that this corresponds to. So just finding the slot that we just changed in this array. Then we will take the player's inventory equipment component. We will get the inventory. And we will directly just set an array element. This is just a like brute force way to make this work. Again, we don't have a very like modular and procedural way to deal with these inventory slots because they're pretty one-off. So a lot of this is going to end up being more or less just hard code. We'll make the item slots here, and we will get the inventory slots from the updated slots. We can just split that. Has item can just be pulled through, stack size can just be pulled through, item asset can just be pulled through, and the slot metadata can just be pulled through. Index, you might be able to pull it through as well, but that's why we did this finding thing. This is just a little bit more secure, and I've had so much trouble with this system. There's a little bit more secure method, just helps solve potential like edge case issues. And we'll also do the same thing with hooking that up to the actual index for the set array elements. Once that is done, we'll use the player equipment's inventory and just call inventory changed. Which brings me to the next thing. So let's put this back with a sequence actually, because we do need to put this in like a separate little thing. And we're going to get our player equipment inventory and we will assign inventory changed for this. And we'll hook that up into our sequence node before I forget. And we'll use this exact same array here to make a for each loop again. Anytime we go and update the inventory, we want to just kind of like redraw that item slot. So we hook this up, we get the inventory array that we have, then we get a copy of whatever index we're at when iterating through, and then we can set the inventory slots here to whatever we get in there. So what this will do is it's kind of circular what this does, but it will make sure that everything is 100% the same between what the inventory slot shows and what is actually in it. Because this side over here is taking what the item slot has in it and then setting it to the array element. And then this is taking that array element and setting it back into the slot. This step might not be entirely necessary, but once again, this entire equipment system's given me such headaches that I just built this in as a little bit of security. Anyway, once we have done that, we can just redraw the item slot for all of them. And that should now allow us to also functionally have our equipment sorted out. So let's pick up a sword and put it in our sword hand. And then we can just put it in a couple of times. This is good for testing to see whether or not it is breaking with any of these other item slot indexes. Doesn't seem to be. We can save, take it out and load, and it will be back in there and everything works perfectly. So now our save and load system works for everything in the entire game. And you can start implementing this however you want. Again, the equipment system is a little bit iffy. If you're going to be using this in your own game, you probably want to redesign it and do with it as you need. This is just a basic framework of how you could implement an equipment system like this. Everything else is very like modularly useful, so that is very good. Anyway, that's the end of our inventory series for now. Anyway, this is the second like chapter of it. If there's any more questions and enough of them pile up for me to start making even more follow-up videos, I will add them together into like a third chapter. But for now, I think this second chapter is actually longer than the first one. So we're going to round it off here. Everything is now more or less production ready, I would argue. I'm going to be cleaning up a lot of this stuff. I'm going to be commenting the code and then it will be ready for the patrons to download. By the time you're watching this, it will be ready for download and hopefully has been for a while. So if you want to just get this and don't bother with setting everything up yourself, there's a link down below in the description for both patrons and YouTube members to just get this and just kind of roll with it. Thank you for watching, and we'll be back with the next fun thing. And a very big thank you to all of my Patreons. You can see them on screen right now. If you want to help out supporting the channel, there's a link down below in the description to the Patreon page. A huge thank you to my Cave student tier supporters, Earl Monteval Erno, and my Cave Digger tier supporters, Sir J. Thomas,